What's going on, ladies and gentlemen? Welcome to episode 160 of the Arc Junkies podcast. I hope you all had a great Valentine's Day. I know I did. I went axe throwing with the wife and some close family, and we had a blast chucking axes and tearing up the bullseyes on the targets. I found the whole experience to be a great stress relief. I've never done any type of axe throwing before, and at first I was all over the place. I couldn't get this thing to stick to save my life, but after a few practice throws, I was killing it. I highly recommend if you've never thrown an axe, if you have a axe throwing place near you, you got to go check this stuff out. It's a lot of fun. So in today's episode, at least in my opinion, is freaking awesome. Today's guest is none other than Bill Komlos. Bill is an English major, turned welder, turned welding engineer, and now develops some of the craziest welding procedures for some of the coolest projects that are out there. Bill has an amazing story, and he's worked on all kinds of cool projects. He's done some stuff for the military, CB&I, Aerospace, and most recently, he's created a welding procedure to weld a man-made metal that has to be installed on the Mars rover Perseverance that's actually going to be landing on Mars this Thursday to collect all kinds of data about the planet. It's been traveling to Mars for the past 6.5 months and has traveled over 300 million miles along its journey. Bill is just a fountain of knowledge, very entertaining dude, and I'm sure you're going to enjoy his story. Before we get into his journey, I want to take a moment to thank the supporters of today's show. Today's episode is brought to you by IsoTunes. IsoTunes are the next generation of hearing protection and my favorite piece of PPE. They're Bluetooth headphones that meet the requirements of OSHA and NIOSH to be used as hearing protection in the workplace. If you're not already using hearing protection, you should, and IsoTunes makes hearing protection fun. Now you can listen to your favorite podcast or playlist without deteriorating your ears. Check them out today at isotunes.com and use ArcJunkies10 at checkout and get $10 off your first pair. We're also brought to you by Rockmount Welding. By now, I'm sure you all know about their world-class maintenance welding electrodes. But did you know that they also offer some other great products to help get your equipment back online? As a welder, you're going to spend about 20% of your time devoted to arc time. The other 80% is getting access to the weld area, fitting and fabricating parts and components, so it stands to reason that you should invest in some high-quality consumables to make that 80% more productive and faster. Rockmount offers a full line of consumables to make your life as a maintenance welder that much easier. Check out all their Rockmount's abrasives, cutoff wheels, flat discs, carbide burrs, chemicals for welding such as cutting fluids, anti-spatters, and degreasers. In addition, they make some amazing drill bits and saw blades. Everything you need to get the job done fast and reliable. Check out their full line of products at rockmountwelding.com, and when you place your order, tell them the Arc Junkie sent you. We're also brought to you by Everlast Welders. If you've been on the fence about shopping for an Everlast to start your side business or your welding journey in the garage or small shop, I highly recommend you start with Everlast. My all-time favorite Everlast machine is the Lightning MTS 275. It's a great multi-process welding machine that does it all. This thing's capable of MIG, AC, and DC TIG with high frequency or lift start, stick welding, and flux core. Why spend twice the amount of money to buy two machines when you can be done with just one purchase? You're saving money and space with this beast. And now you can finance for as little as $55 a month. That's less than the price of an energy drink per day. It's time to get off the fence and take advantage of the great machines at great prices. Check them out today at everlastwelding.com and use Arc Junkies in the comments section at checkout to get that free Nova foot pedal and TIG torch upgrade when you buy any machine that comes with a stock foot pedal. That's a $100 value. All right, everyone, let's go ahead and get into this episode. Fire up your machine, drop your hood, and turn me up 5.
You're listening to the Arc Junkies podcast. Helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, ladies and gentlemen, on with me today is Bill Komlos. This dude is, I don't even know how to, words can't express it. This is a very interesting character. Bill, I'm kind of speechless. Go ahead and tell us a little bit about your history. I know you're a welding engineer. You got your own company and everything. But you do some really, really cool stuff. Like I thought I did some cool stuff because I got to weld on some roller coasters out of Disney, and I got to help build the SpaceX building. But that's nothing. Let's get into it. I'm excited.
I'm after you, man. Well, my first degree is in English, okay? So I'm the most well-read welder you've ever met in your life. But of course, having an English literature degree, especially back when I was going to college, really meant that you could go sell, books at your local bookstore, or you can maybe teach classes or something. Or heaven forbid, you have to write. Oh my gosh, I don't know about that. But that's what I did for school. But during my summers, I worked with a gal who was, she was a metal artist, a metalsmith, and actually had stuff in the Art Institute. I grew up in downtown Chicago. So she, kind of took me under her wing, kept me busy during the days or something, and I got to play in her art studio, thinking I was going to be an artist too, okay, because I like the Art Institute and I like that whole style. And my school wasn't tech heavy, okay. I mean, everybody was going to move on to college, if you will. But we all know that not everybody needs to go into high education, if you will. I did, and I've had a good time with it. But all my money has been made from 2 years I spent at Utah Technical College learning the skills-based program. We were lucky enough to have, old Boilermakers teach us the craft and things like that. We also spent, gosh, I think a quarter and a half just oxyacetylene pipe, and that's not taught anymore. It's AWS. It's not even part of their Sense program. It's all
Right.
electric arc. I'm old school. Anyway, from there I went on and started working in the shops. Got into an ironworker indoor shop. They called it indoor ironworkers. So I apprenticed and learned my bevels and things like that out of books. We had the Smoley's tables. This is before the calculators that would give you sine and tangent and stuff like that. So we were doing it all out of books that would break down degrees, 60 minutes, 60 seconds. And so we could find all of our slopes and angles. We learned how to fit with framing squares. And that was my big problem in high school is I'm a visual learner. I need to see it. I can't just have somebody talk to me at it. I got to be able to spin it in my head and look at it, if you will. So I kind of was lucky enough. I had a really good algebra teacher and I had a really good geometry teacher. But when we got into trigonometry and stuff, I just lost it. I just thought I couldn't do math, and I'm remedial math all my life. So I got in with ironworkers, and I'd been a welder a couple of years before, and they need fitters, okay? And so you're going to learn how to fit. You got to learn how to use the tools. Well, fortunately, learning how to do slopes and bevels with a framing square, I could see it. If somebody's telling me to hang this on a 12-on-4 slope, all I do is set it on 4 inches on one side of the framing square and 12 inches on the other side, draw a line, and now I got it on my bevel square. I can see that stuff. So having ironworkers teaching me how to build stairs glued it all together for me. And so I went back and when I started going into engineering, into the project management side of the world, one of the guys there had one of the first 50-step Hewlett Packard calculators. And he taught me how to program that thing so I could start programming uh, uh, plates so that we could burn plates out on these burning tables and roll them into cones and stuff like that. So, complex angles, if you will, or offsets, squared around offset branches and stuff like that. And this guy taught me that stuff. And so I was able to see it. So later on, when I was in my 40s and decided to go back and to college to learn why do welds crack, why do welds break, I could handle taking the calculus class, and I could handle classes, and I could handle doing the matrix and linear algebra, which is, oh my gosh almighty, that is some magic stuff. When
Yeah.
you start playing with numbers, it's poetry. You've left language behind and you're learning a third language. So it's to be able to manipulate spatial shapes like that graphically. I remember having to build a 35-foot radius platform to go around one of these smokestacks so the planes wouldn't hit it, but they needed access, a couple 100 feet up the smokestack at one of the mines. And And the way we built it was we took trammel points and put a 35-foot long rod out there and just scribed the arc on the floor and then put stops on it and used a torch to flame straighten it or flame bend it into these stops that we built.
Now that's ironworker math right there. I did the same thing out at when I was working for the ironworkers out at Disney. You know, we'd have a big concrete pad. Laborers would come in and paint it gray. Now I got a nice gray canvas to weld out or work off of. I'd take my set of prints and start doing stair stringers and, you know, handrails and all this stuff and just build a life-size template right there. You know, so I could run over to the saw, cut a piece, and drop it in place and say, I know it's going to fit when we take it out in the field.
Well, on that same note, I like to go to these antique steel structures like the Saugatuck mine, a mill up and outside of Boston from the 1700s and stuff like that. It's magic. We don't do a real good job on industrial history, and I try to remedy that in my own little world, but we don't talk about the giants who were standing on their shoulders. Well, I recently was able to go to the Bath Iron Works, okay, and you know, I know some guys up there, but they have a museum to the Bath shipyards. Uh-oh, where'd I go? Sorry about that.
You're good.
The Bath shipyards, and they got a whole museum of it, the originals, and they've got their templates scratched out still in pencil and graphite on the floors of the fitting room. Wow. How to build a bow of a three-masted schooner. And what you're talking about is you had a whole layout there. Well, now take a look at what these guys are doing in the 17 and early 1800s. You're seeing their marks just like you and I do today.
That's awesome.
Yeah, it is. So anyway, so I came out of school because I want to be a welder, but I have no artistic talent per se. So I decided better be a technician instead of an artist. So I dug into it and I learned the fitting. I went over Chicago Bridge and Iron and I knocked my teeth out as a fitter. That's why they're shiny. You know, we're all bosses, right? We got a little 4-pound hand sledge and I was using a mushroom-headed wedge trying to dog out a hopper shell and stuff. And boy, I just kissed that thing and saw it come right at me. And next thing I know, my teeth are on the fitting table down to my feet. Iron workers paid for a new set of teeth. I racked up a couple hours overtime. So I guess, you know, and I got a nice smile. I can't spit through my teeth anymore, but I can smile broad. So
you got to take what you can get.
Peace. So anyway, after that, you know, and you're working hard and it's tens and everything like that, fun stuff. But, you know, back then we didn't even have heat in the shops. You know, it was these salamanders. You're just burning, you know, you're just another tool back in the 70s and the 80s. Now we got, it's a lot different. They don't tell you you're showing up to work tomorrow at 6 o'clock. They ask if you'll show up tomorrow.
Yeah.
So,
yeah, it's a different mindset nowadays.
You kind of have to break me because I'm more into the command mode than I am trying to work around with people. So I decided, so I jumped ship from Ironworkers. One of the guys who I'd worked with before, his dad was superintendent of Chicago Bridge and Iron. He told me they're hiring. So I went over and I got to CBI as an A fitter, but a B welder. So I spent most of my time doing parts, but we were doing the Whoops nuclear reactor. We had offshore drilling rigs. Everything was big at CBI. I mean, 2 inches thick was nothing, you know. And so you have to learn. They taught you these techniques, you know, like when you're teaching in school. You take your 70-18 test, you go side to side and pause, burn it in. They're doing your nice vertical up and stuff like that. Well, if you're trying to do that, they taught us to fill 1-inch plate with 70-18 in 3 passes. You weld a vert down 70-18 in the back to hold the slag in. Then they don't teach vert down 70-18 anymore. And actually the manufacturers say it cannot be done. Ha ha. But it's just jack your heat up to 150 like they show on some of the manufacturers cut sheets, 150. Well, that's vertical down welding, okay? Because it blows this. It's a tough trick, don't get me wrong. Mm-hmm. But if you do your vertical down with 70-18, then you go up with it with 532, because now you're down at the low end of the 532 70-18 range. This is the kind of thinking that CBI was getting into, because they may have a guy 100 feet away from the crank of his welding machine. So you got to learn how to work the puddle, and you got to learn how to fix your amperage with speed of travel. It all comes down to heat input, but instead of dinking around with the heat and the voltage or anything, the welder has to do that with his hand and speed of travel. Otherwise, you're going to spend all day climbing up and down ladders, and who wants to do that?
Yeah. It
You know
sucks.
what I
I've
mean?
been there.
Yes, yeah, it's just not to do. So they were thinking ahead. Everything they did had been engineered since the 20s. That was the magic of working with CBI. They changed the name to CBI. Was it had all been done. They built some of the greatest things we've ever seen, and so we're picking up on that kind of stuff. And so I learned a lot about 3D welding, I call it. It's not just going up a little at a time. You're going in and out and filling. I mean, I can't pass the Lincoln Vertec test because the
Don't feel
Lincoln
bad.
my wife could. My wife could, but I couldn't. It just was too much. My hand works the whole time when I'm welding. I don't just target and drag. I'm, oh, wait a minute, I got to go back and put a little heat in there and get that tail to move along. So I failed in Lincoln Vertex.
I tried one. I went up to one of their educator workshops, and I'd been hearing all about this Vertex and stuff, and I was like, well, let me give it a shot. And I think I scored like a 70, and I was like, man, that thing's a piece of crap. It doesn't know what it's doing. But in hindsight, I actually have one in my classroom, and I teach students with it. And if you've never welded before, it is a great teaching tool. But you can't put somebody that's welded before and put them under that hood. They're going to be all over the place. But if you've never ran a bead before, never ran an arc, it's something good to develop that muscle memory and proficiencies and the theory on it. But yeah, if you're a welder, it's not for you.
No, but you're right on the mark. And as far as getting people out to the field as fast as you can, the latest data that I've read is you can get somebody ready to take a certification test. Maybe they're not used to the arcs and sparks, but as far as where to target their stinger, you can get them in 10 weeks. You can get them out there taking a certification test.
Mm-hmm.
I still like teaching oxyacetylene, but bottom line is production demands are so high these days, you got to do it all by wire.
Yeah.
And you got to get people out there as fast as you can, but pluses and minuses.
Mm-hmm.
So anyhow, I left Chicago Bridge and Iron, and I got a job at the Mark Steel Company, privately owned, family owned. They had 3 plants. I started out as a project manager there. And again, I'm in my 20s, so I don't know a whole lot. I crossed paths with one guy there who was the second in command. And the story goes, I was sitting in the office and he's chewing me out. And I sat back and stoked my pipe and thinking about him chewing me out, and I just blew smoke rings over his head as I was fired that day.
I bet that
I don't
went over
remember
well.
blowing the smoke rings, but I was a pipe smoker, and they had a fan in my office to suck the pipe smoke out because you could smoke back then. But so I crossed this guy, and he hated my guts the whole time. Fortunately, he was a drunk, so he'd get fired all the time. But he was also one of the best sales guys in Utah. So I'd get hired back because I knew stuff, and I'd last as long until Big Jim had come back, and then he'd fire me in about 3 weeks. And then I'd go off and learn something brand new. Okay, always brand new. And then Mark had run into a problem. Jim would have gotten canned, and so they'd bring me in to, I wound up running a nuclear bomb simulator. That's the one that was on the cover of Welding Journal. Maybe I sent that Welding Journal.
The one from '95, the driver tubes.
Yeah,
that's an interesting project.
It was, yeah, we had a private airplane that would fly me down to White Sands, New Mexico, and I got this guy to fly us over Indian ruins and stuff I know about in the desert. So I had an air jeep on our way down to the meetings in New Mexico. But that is a magic job. It was. We built the driver. We built all the iron in the piece except for the injectors, which would mimic the fire out of a nuclear bomb. And that Schuff Steel did. But we had all kinds of, the velocity, we had 9 driver tubes. The longest one was 197 foot long, about about 6 foot diameter, 2 inches thick. So that meant that it was just thick enough to where you always had to stoop when you were in trying to set in the nozzles in this thing. It was built out of HY100, which is a high strength, low alloy steel. It's what they make submarines out of. In our project for the Defense Nuclear Agency, we were using HY100 in a tensile application as a pressure vessel. We built pressure. We were ASME and nuke, and we did everything. We're short run fabrication. And so when all nine of it, so the longest was 197 foot long, we were shipping them down to White Sands in one piece. So there were 188 tires underneath that big long one, so it wouldn't just fall through the asphalt. But when all nine of those things blew off, they predicted that the force of the blast was 8 times the force of Hurricane Andrew, and the reaction pier that held the driver tubes in place when they went off, you could drop a pencil at the top of the rebar before they cast the concrete, and it never hit the floor because there was so much rebar in this block of cement to hold these pieces in place.
Jeez.
Yeah, and it was the air bubble would come out of these things and it would bend light. I have a photograph kicking around where you're looking at the mesas outside of White Sands Missile Range, and we were only about 30 miles away from Trinity, where they've set off the Fat Boy, the first nuke bomb. We're up to the Socorro side of things, and come on, Bill. Pardon me. But we always say, well, if any of our flanges fail that are holding it into this concrete piece, well, at least the missiles, these things are going to turn into missiles, and they'll shoot all the way from White Sands, New Mexico, up to Canada before they land. So we're going to be in good shape on that.
So what were these things for?
Defense nuclear. Those become military things. I know it was to test the hardenability of back then the Bradley vehicles and stuff like that, to see if they could, how they'd respond to a nuclear bomb.
Okay.
And we built the driver tubes, built the force. Okay, the
percussion and all.
Yeah, Schuff would rain down molten magnesium and aluminum on these pieces to pretend it was the fire of the nuclear bomb. But we built a thing called the louver system that when you blew off all 9 of these things, the force going out was so fast and furious, it turned the inside of this tunnel into a big 300 foot long tunnel or something like that. It'd suck all the air out of it and turn it into a vacuum. And so if we didn't slam louvers shut, it would suck all the air out of it and would make the whole tunnel, which is, monstrous thick concrete, just make it collapse. So these things, I had 128 plates. They're about 18 inches deep by 2.5 foot wide, 128 of them, and they would snap a 90-degree angle in a quarter of a second in order to keep the air back into this thing after the blast. And we built the gears, and outfit Frankie Gear in Chicago built the gears. And actually, it was Frankie Gear that got me thinking about my career. Now I'm in my 30s and stuff, and late 30s. And Dick Mason, who is one of my mentors, he says to me, kid, don't sell yourself short. Wow, well, that's a hell of a statement from a dude from Chicago, multimillionaire, magic machine shop doing spherical gears and stuff like that. And the QA manager from White Sands was coming up to audit us, okay, so it's a show and tell. Well, he winds up taking me out. I take him out for steaks and coffee, okay, at lunchtime. And we wind up just sitting there for 3 hours. I'm getting itchy. I'm 30 something. I know my phone's going off. I got to get back there. This is a $9 million job we're doing for White Sands. Okay. And I can't even remember the cat's name, but he sits back, fires up his pipe. He says, kid, just settle down. I want you to know that I know that that I'm the most important person in your shop today. And I said, well, yeah. He says, so you don't want to piss your boss off by pissing me off. Let's just have lunch and have a good time. I know you know what you're doing. You're good. And just keep doing what you're doing. And we're talking. Now we get into the bullshit side of the world. And he finally says, when are you going to figure out you don't need anybody to tell you what to do? And he says to me, you know, you might want to go back to school again and maybe think about an engineering degree. And he was a professor at U of Mexico, New Mexico, or something like that. And he said, you know, if you go back to your school in your 40s, you know, that's okay. People may think you're kind of slow, but it's still a good thing to do. But if you go back to school in your 50s, people are just going to think you're stupid. So you better make a decision now before you get into the stupid range. And he and Dick, that project just really got me thinking about, well, maybe there is life after the shops. And next thing I knew, um, Big Jim had come around. I was now in contracts administration because I'm a tiger. I can read and I can write, so I could read contracts and tie people up. And we got one of those Disney jobs that we had to fist fight. They back charged us $250,000. This is when I was subbing out for people. They back charged my customer $250,000 for not cleaning up the site. And by the time we were done, we had gotten $2.2 million back charge because their scheduling was so screwed up. It took me 6 months to put the claim together.
Sounds about right.
Yeah, right. Well, you know, you got to make some money on the job.
Oh, yeah.
So all of those kind of things stacked together has given me a 360-degree view of the business. Okay. I know the code side. I know the hammer side from the customer trying to get a Cadillac for a VW price. Okay, that's my world, and so I tend to be on the production side of things, trying to sell parts rather than buy parts. I mean, I do third party work now and things like that. Don't get me wrong, you got to eat. But my attitude in working with iron workers, and they're union craft, and so they're sitting tall in their saddle, you know, so they get attacked by everybody. And I've been working their program. They had me rework their apprenticeship program, the welding procedures for them. So I've been sheet metal, rebar, TKYs, all, and the boys just pay me for it. And not only that, they pay me to witness the tests with a digital multimeter. So I'm watching every shake in the guy's hand is changing voltage. Every step, every way he sneezes, he's changing amperages, okay? And I'm seeing this stuff. And I've been seeing it for 30 years. So when you give me the heat input formula, I know, don't worry about the amps and volts. It's going to be the speed of travel. It's going to make the greatest impact on you controlling your heat of input. And in order to do that, you got to have welders who are smart enough to understand that they got to move a little faster, because you might be standing behind them with a stopwatch. That's how we used to weld chrome moly. The inspectors, you'd see him in your hood. You know, you'd see him in the shadow in the back of your hood. He's sitting there with a stopwatch, making sure that your speed of travel is fast enough, pardon me, to stay. We tried to stay below about 35, 40 kilojoules for chrome mollies typically. And so you get used to that kind of scrutiny and that kind of, you got to make it work. So I did that for a number of years. And then I decided, Mark Steele had got me into the engineering side of things. But again, I couldn't survive because I'd crossed the vice president of sales. But they kept coming back, and we did lots of Inconels, lots of stainlesses, lots of carbon steel. I had 3 plants. I wound up being their welding supervisor / QA manager, okay? And for a long time, just the welding supervisor. But I had 250 welders and 3 plants that I was responsible for. And I took my breaks on the floor. I'm not an office welding engineer at all. I did, because you got to talk with folks. And if you're going to stay walled up in the ivory tower, you're going to come out in your leathers, and they're going to say, like Rube used to say to one of the guys who signed on as a welding engineer back when I was the QA manager before I took over the welding supervisor. He says, "Oh, you coming out here in your leathers to whip me and beat me? You get somebody talking to you like that on the shop floor, you're going to run and polish your shoes back in your office pretty quick." But I'd take breaks down there, and we'd be hiring Latino speakers and stuff, and I can speak Spanish a little, so I'd go hang with them, and they'd give me tamales for lunch. Good family stuff, but it was like being in grade school. Everybody had their little camp, and I just flowed in between them. So it was real, and any one of them would give me their shirt if I needed it, just because I'm out there. When I was an inspector, you didn't go to the office. And that's changed now. Companies are keeping their inspectors in cages and letting them out of cages nowadays. In the old days, we were on the floor, support for the floor. I had 4 bays that I had to roam around in. I had my framing square and my chalk line, and you just kind of boogie around, and you're keeping up on nozzle locations, look for the heat numbers, just keeping the show going, and you got to stay ahead of production. If you stop the production, you weren't doing your job. This quality first, production, safety first, quality second, production third. Well, I buy all of those things, but it's the safety first is the only real one. The rest of them is a quality guy. You better pick up your skirt and start running fast, because if you're getting crowded by production, you're not paying close attention. You're paid to get in front of those folks. So. Mm-hmm. Yeah, I'm not one of these. I got to be spoon fed. And so being on the floor is the only way that I could really keep track of stuff, so that it didn't turn into disasters at the end of the job and stuff like that. So we did nuclear. We've done machinery stuff. Like I said, we were real lucky with a lot of different. We did claddings. I had a sub-arc, a strip welder sub-arc, to where I could lay down a bead 2 inches wide, 3/16 thick, and when we were overlaying tanks to run sulfuric acid, you'd build them out of mild steel, like a A572. Grade 50, nice, easy stuff. But then we'd overlay it, because we couldn't. There wasn't enough time to wait for the explosion-clad fabricators to give it to you. So we just got this strip welder and paralleled up. Please let me be right. Paralleled up 2 power sources, got about 1,500 amps going, and just spin this thing into the shell's like red hot, but you're just pouring it in, and mild steel doesn't matter, and then going in short arc to tie it together, because we don't want a lot of pickup. So I got into controlling the weld pickup by which weld process I use. Short arc doesn't have much of a bite. It only bites about a 32nd of an inch, whereas I'll get a 16th of an inch in a flux cord. And a sub arc, I'll plow through an ace 3/16 without batting an eye. So you can imagine how your puddle's just churning and mixing, and you don't really want to do that when you're welding some of these AL6XMs to a carbon steel, or heat sensitive kind of things. Mm-hmm. So I got used to playing with alloys, but because I'm a self-trained welding engineer. It's all school of hard knocks, because I was a welder. I got ideas for and I read. Like I said beginning, I'm a well-read welder. And so I could go into the welding handbook and it wouldn't put me to sleep. Okay. I could do it. If I read it 3 and 5 times. And when I was inspector, gosh, I'd spend lunches just reading D11. So I'm kind of encyclopedic. And then working in ASME, we were doing nuke work. It was still Section 8, Div 1, Div 2. Div 2 are the lethal vessels. I think we had section an S stamp, but I can't remember. There was many years ago I was doing that, but then I did a lot of piping when the tar sands were going up in Canada, so that got me into the B-31. And I've had to fist fight inspectors, because the Canadians didn't like USA Americans doing work down here and sending it up to Canada. So there's always fights about, this isn't right and that isn't right. And so I got used to going up and representing my customer to put the job to sleep. And, from 750 welds being rejectable, well, we got 3 welds rejectable, and we can build them up externally. We don't, you don't have to, it's not a big deal. Mm-hmm. So I got used to that, and then, like I said, the Disney job where I landed, over $2 million back in, working with the company. I just got kind of used, and my experience with Mark Steele as a contracts administrator. My goal was to back charge customers about $30,000 a month, and sometimes they wouldn't pay, sometimes uh, they they misconstrued the code, and so you'd kind of have to go in and negotiate on that, and just things of that nature. But I got pretty good at it. And you also know when you're out to the field, they're going to have about four guys talking to you at the same time. So you have to learn how to filter things out and look for the spot where they've got all the junk and all the boxes stuck. And then start plowing into that because they won't move the boxes. There you find out where they missed the cut and they had to gap it bigger than what's allowed. And so now they threw the angle of the dangle off by 10 degrees. And by the time you've moved out to 100 feet, that thing, it's a mile away. So nothing works. So yeah, I've when I'm a contracts administrator, I'm a liar. Okay, it just comes with the territory. When I'm a quality manager, I'm eight corners blockhead. It's the code, black and white. When I'm a welding engineer, I know how codes are written and I respect them and stuff like that. But I can get an engineer to override the code if I just say the magic word money. It's going to cost you money if you do it that way. This way you can do it without money. And the 90% of the time they'll go with it, okay?
Yeah.
Because it's all
What's the cheaper option?
money for those folks, okay?
Which option is not digging in my pocket?
Yeah. And so I can pretty well say, we can test for this if you want to, but it's going to be $1,100. Whereas if you just wave it away with a stroke of a pen, it's not going to cost you anything, and these guys can go back and do what they always have been doing before. It's like working with grading people. I had a job where the airport, it was Colorado Airport, they specified A36 grading, okay? And well, you don't make grading out of A36. Go to the grading manual. They make it out of 280, A283 or some, another mild steel, but not as classy and as well tested as A36. Well, excuse me. So they bid it they bid it as their normal grading, and I'm up against a major international airport. Their QA managers, no, we're not buying that stuff. So I'm the guy in. We can't buy it that way. What So it gets kind of upset, and as an inspector, you kind of go, well, I'm just the singer, not the song. You can make me park in the back of your parking lot because I don't care. It just burns more hours. I'm going to make more money. So whatever you want to do,
Mm-hmm.
So that was kind of my world. Well, I got tired of it because in the steel fabrication, that seems to be a lot of tigers and bears out there, or Tyrannosaurus rexes will eat you alive. And I got tired of trying to be a Tyrannosaurus rex. So I got into, I stumbled into machine shops. I was laid off from Big Jim. And I was working as a CWI and as an inspector, okay, third party guy, independent, for this company. And they put me into this machine shop because the machine shop's quality manager had diabetes and was going blind. And the machine shop had gotten debarred because the quality manager couldn't keep up with stuff. And the superintendent, who is also one of the owners of the company, he's just pushing stuff through, okay, and because he's an owner, okay, and they debarred him. But the problem was the machine shop was sole source for all kinds of weapon systems parts. This was just before space shuttle kind of taken off. They had we were the only people in the country who were allowed to cut parts for some of these things. We were certified by Hercules back then, which has become ATK over the years, and Northrop, ATK Northrop now, I think it is. But we were one of a handful, and it was because of my welding experience, handful of companies certified to weld 4330s and 4130s in 40s, for space shuttle work or space work, aerospace and weapons system. Because, It's tricky to weld if you're trying to get the hardenability up. If you're just welding those steels with a 70 class electrode, it's not as critical. But so you get used to that, and then in the machine shops, it's all aluminums, lots of aluminum. So that gave me aluminum experience in Magic Tony and his mentor there. So and we did 2219s, copper bearing aluminums, which was a monster to try and weld clean. But it got me used to the aluminum side of things. Well, then I went up and I became a welding engineer. And again, I don't have a degree in welding engineering. This is Salt Lake Community College, and my ability to read and write and 360 degree of the business, because I've been in these I couldn't hold a job, so I'd come back at different positions all the time. So I left the machine shop because I had a good job, but I wasn't going anywhere, and they turned it into a cash cow, so you could see where the money was going into recreational vehicles and stuff instead of employee bonuses, which we used to get. So peace, they're the owners. They do what they got to do. But so I left, and I wound up working up at Autoleaf, which is an airbag manufacturer here. It used to be Morton Thiokol. They were the first airbag outfits. They came out of the Thiokol Aerospace stuff. And that's where we got the airbags. It's all comes out of space shuttle work, okay? And we had that, and the explosives. Remember that they have an explosive charge to set stuff up. Well, that's what Hercules was back in the early days of the Red Man rockets and stuff. It was Hercules Dynamite Company. So it's these explosives people that have pushed our aerospace where we are, and fun stuff, But so lots of different alloys and machining has got a whole different sense of tolerances, and you're in the aerospace. So quality isn't, in the structural business, they'll like to say quality is overhead and underfoot. Okay. But in aerospace, but as you move up along the nonconformance curve where to fix things, it costs more and more and more money. Doesn't cost much to fix a double stamp flat washer. You throw it away and put in a new one. It costs a lot of money to put glasses on the Hubble telescope. So the owner of Hubble telescope, he's going to listen to his quality guy. The flat washer guy is going to say, who cares? I've been in business 30 years. Nobody's cared about throwing away a flat washer. So you may as well not be trying to do nuclear work at a flat washer fabricator, even though the fabricator does a great job. You're just not going to get that anal retentive satisfaction of they're going to stop the job and we got to get this per spec, that kind of thing. And I'm a believer in it. But I got away from that and got more and more into repairs because I had so much diversity. And then when I started working for a mine in around about 2004, by 1999, I'd started ArcTech LLC and working on my own. About 2004, US Mag, and I'm still a surveillance guy and a welding consultant for US Mag. They make magnesium out of salts. Well, magnesium eats nickel. So you can't just use Inconel crucibles to melt the magnesium down, which melts through 1500 or something like that. And so you'd love to use one of these stainless vessels and stuff. Well, they were using clad. They were cladding 410S, which is a ferritic stainless. It'll crack like crazy, but it doesn't get hard like martensitic. It's got virtually no nickel in it. 410S is the ferritic. 410 itself is the old martensitic stainless steel, like you can make a knife blade out of. But the ferritic won't get that hard, so it's a little easier to work with, but it's still lean in the nickel. Well, magnesium eats nickel, and so they blow out long seams, and it would just, of this 410 stainless, just because the 410S ages, and the grains get big, and they finally just kind of fall apart, because mines equipment's just there to be used because they're on production pounds per hour, right? And so you'll take a $70,000 crucible and you may heat it up to 1,500 degrees is what they're saying. But if you look at Young's modulus in ASME section D, you've lost more than 80% of your strength at 1,200 degrees. So it's like jelly at 1,500 degrees. Well, they clad it with Inconel, an Inconel 601, I think it was. It's aluminum bearing Inconel. But it's 60% nickel, but you couldn't have that touching the magnesium because magnesium just eat it alive. But once these long seams would blow out, well, then the cladding was gone. And one of them, like it's on my website for arctechllc.com. And Lau, this guy who he had to weld up one of these things. We poured in 300 pounds of Inconel filler metal 82 at $35 a pound into this crucible to repair, once we repaired the long seam, to reclad it. And it only lasted 9 months. And I'm going, oh gosh, I'm never going to get another job from these guys. And son of a gun, I'm still working for them 10 years later, So I must have been okay. Another story with US Mag, rebuilding their crucibles. You're trying to do them cheap, Well, I made the mistake of not having the guys grind back to clean metal at the very top on the interior. So we had some really grody metal that overaged and gotten carburized and stuff. And so we're welding this thing out, and it was A36 clad with 309 stainless. And the 309 was failing because the engineers, 309, it's an austenitic stainless 300 series, right? And so it ages. We were taught you don't run it. It's not good for temperatures over 800 degrees, and you don't want to cycle it much and stuff. Well, we got these things welded up with 309. They put an A36 3-inch flange on top of these clad steels just to hold them into the furnaces and stuff. Well, so we used 309 stainless on. Well, that stuff just goes to hell, and they'd covered a long seam. This particular vessel was done in Germany, and they welded it out with 309, and the aging finally started the stainless steel cracking on us. And we were welding out, got it nice, just about finishing it up, and the guy's putting in the sub-arc pass on the inside, and he hits some of this grody metal, and all of a sudden you see one of these sparklers go off. You know how you hit dirt and it sparkles on you, Well, it just kind of like that. And that thing, the 7-foot diameter can, what, 1.5 to 2 inch thick with this cladding, it cracked. The head cracked all the way around the head at the speed of sound, just boom. And I was down at AWS at a meeting on TAC, and I get this phone call, your welds are cracking. And I'm, holy cow, that kind of thing. Well, tell me what's going on, blah, blah, blah. Well, they got all scared and everything. And I knew what I had done. I said, well, you got to grind this off. You got to take it down to bare metal. I gave you a bad welding procedure. Well, they wouldn't fix it until I came back into town. They'd run their emails up to the head of US Mag and up to the head of Mark Steele. And I finally had to say, hey, we all got our jobs to do. You do what I tell you to do. And I'm telling you to start cleaning that weld out, get rid of the crack, and get down to bright metal. I'll see you in a week. And they had to do it. But I mean, oh gosh, they were dragging feet. They just, it wasn't much fun, but we got it done, and life is good. But so I've had a lot of opportunity with different alloys and different ways of doing things. And that's what I carry in my back pocket. And that and experience with excellent journeyman master welders who've given me their time and given me their knowledge. And of course, it's one of those, well, you seem to be smart enough to know what I'm talking about kind of thing, instead of, somebody who says, I got nothing, but give me everything you got. That's no way. Got to treat these folks with respect. They've got years in, and nobody's stupid. Nobody is stupid. I don't care what degree you've got. So, so that's my big forte. I could go anywhere in the United States at one time, and if I needed to get into one of the ironworker training centers, I just make a phone call. And sometimes I've had to do that in order to prove to engineers they don't know what they're talking about. And keep the job rolling. It's important to keep the jobs rolling and do a quality job. So I taught for 12 years at night, like everybody's supposed to do when they're in their 30s. You know, if you've been a welder in your 20s, you know, you're going to give back some and teach. And so I did that for 12 years and was teaching pipe at that time. And all the time reading. Um, but then, like I said, the White Sands job, the missile range, got me thinking about better get smart. So I went back to school in my 40s with the goal of being a professional engineer, because then I could stamp off my own work as an inspection agency and make the big leagues, you know, go for the big time. But I got wrapped up in structural engineering because the structural engineers are the ones who make the deals. They're the ones who shake hands and this is the deal that sticks. Quality guys, no, we don't have the right to tell you, or we don't have the responsibility to say this is how it's going to be done. We just can tell you, is it meet requirements or not, you know? And so you got to narrow focus is that. So I wanted to be to where I could thump on a table and say, you guys are hosing us and we're not going to take it, that kind of a thing. And I learned how to do that well. But because I was at 40s, and we have one of the top we're a top third tier structural engineering school at the University of Utah in Salt Lake. And we do a lot of earthquake stuff. As a matter of fact, some of the great earthquake mitigating machines that have been built, some of these buckling restrained braces, kind of seismic shock absorbers. And if you knew how they work, you go, well, duh, it's just metal upsetting. Well, it's enough to absorb the seismic accelerations, okay? So we do earthquakes out here. At the University of Utah, we have a 2 million pound RAM, so we can test full size structures. And I got on it with my patent. I got a patent for my master's thesis, a cryogenic way of stress relieving welds. And I wasn't doing just one weld joint at a time. I could do whole bays because I was shrinking steel and then welding up a closing seam. We were using W14 by 311s cut into WTs to do this. And I did 15 joints like this. And we had strain gauges all over and linear variable displacement transducers, electronic rulers and stuff. So I really got to see what's going on with welding jumbo shapes. I mean, Dwayne Miller at Lincoln Electric listened to my lecture at the National Steel Conference, and we've become friends. I'm not as well published as him by any means. I didn't get my paper published in the National Engineering magazine, but he liked where I was coming from because we'd shrink these beams. I got them to shrink 11/32 of an inch with liquid nitrogen. And these are 2-inch thick flanges with 1.5 inch thick webs, okay? And to move these things. So we'd shrink down for the closing seam. And I welded up. I have minus 300 degrees at my back, giving me arthritis. And I got 2,700 degrees, well, 10,000 degrees at the electric arc for a flux cord NR232. Well, I was using Core Shield 8 to weld these things up. And then when we take off the shrink, and the beam would expand back to its normal length at ambient temperatures, right? Well, I'm just jacking into these welds. I erased all the tensile stress in one direction and replaced it with a compression stress. When I cut out my beams, instead of the cut snapping apart because the columns go in, they come hourglass once you weld in a beam across them, cut them and they'll snap open to their original size, okay? When I cut my beams after I put in the compression on them, they'd slam shut and I'd have to keep cutting in order to get them to where they'd stay open enough to where I could cut out pieces. So we've measured, and there's always a little flakiness in experiments. But I think we removed about 25,000 pounds tensile residual stress and replaced it with about 15,000 pounds per square inch compression stress. At that time, you could set off a bomb next to one of these joints and they won't crack out. And when you're dealing with really thick sections, thicker than 1.5 inches, or 1 inch even for pressure vessels. They get worried about triaxiality, where you're locked up in all 3 planes, longitudinal, um,
Transverse.
transverse. Yeah, well, that's longitudinal, parallel, axial. I'm lost now. I'm thinking about too many things, but it's 3 dimensions, okay? Up, down, sideways, and in and out. Um, but if you can get one of those planes to be in compression, the rest of the structure is going to jiggle nicely. And we're just doing that with by shrinking the steel, and I can do it at real time. We shrink it while the welder's welding on it. But
So you're just spraying liquid nitrogen on the backside while he's running it in there?
now you build a tub. We actually, I had a dewar of liquid nitrogen given to me, and it take about take me 6 hours to weld one of these joints, because we pump in about 18 pounds of weld metal into just the flange.
Jeez.
Ironworker, my buddy Red, Ironworkers donated my welding equipment. They donated the filler metal rod, DNR 232. They were dumping the junk. Pardon me, Lincoln. They were dumping it on me instead of the core shield stuff. But anyhow, and they gave me labor until it got dangerous. Once we started playing with the liquid nitrogen, I kept folks out of it, and it was just me welding on it.
Mm-hmm.
But Red could knock out these joints in about 4 hours. But he's doing it 8 and 10 hours a day, that kind of a thing. But so I went up and I got my master's degree in structural engineering. I even quit once because one of the professors pissed me off, because I don't think the way the college, like,
wants
again,
you to think.
I need to see it,
Yeah.
right? And if I don't see it, I try. Fortunately, there's today's schools, the work is so big, you need team teaching. So you're always doing projects in a team. So because I write, I could write the papers and let the brainchilds do the math. And I'm in there with the A team. So I wound up graduating with honors, oddly enough, from being a remedial math guy. Well, I guess it's being married and having kids. You're settled down anyway. You're not worried about what you're going to do on Friday night.
Yep. Homework. That's what you're going to do.
So maybe I just grew up enough to be able to handle the sit down. But so I went through it all and got to have a pretty local reputation of having a unique perspective on welding engineering, if you will. Because AWS, when you talk to a lot of the welding engineers, when they're talking carbon steel, if it cracked, it has to do with hydrogen. If it cracked, you got hydrogen. You got to be using well, sucker, I'm welding with normal flux cores. It's 16 milligrams of hydrogen per 100 grams of metal, okay? Whatever. It's low hydrogen. If you want me
I think you're muted.
Oh, shoot.
Oh, you're good now.
Sorry about that.
No, you were right at 16 milligrams of weld metal.
Okay, so I'm just saying, with our flux cords, we're by definition low hydrogen. Now I can get super low down to 8 milligrams, or I can go with hardwire and the pulse MIGs, and I can go down, or subarc, and I go down. Well, subarc, I still got to worry about the flux, but with the pulse MIGs, I can have 0 hydrogen, but I still can know that your welds can crack. Maybe you're too thick. Maybe you've locked up your joints so much globally that you're going to fracture it below yield strength. That's what happens with triaxiality. That's what's happened that's what's happening down at the San Francisco Bay Transportation Center on these monster welds. I think they have a bad detail at the weld access hole or something,
Mm-hmm.
and it started cracking from just rough surface roughness, I believe, is what went on. I looked at it some time ago, and so but it's obvious that they've got a problem, and it's not necessarily the weld that failed, it's the connection that failed. The connection's not my responsibility, it's the engineer's responsibility. I do amusement park rides too, and we had one at one amusement park, and the amusement park mechanics are special folks, because they see cracks through paint. We're not allowed to do that as welding inspectors,
Mm-hmm.
but you get a nice coat of black paint on something, and when you see it cracked, you know that something went south underneath it. And then we'll map these things, just like we're doing aerospace stuff. And we may see these indications for Boeing. I've seen the same indication for for 10 years, but we measure, does it grow over time through use? Because they can't build another one of these test facilities. So the engineers are monitoring crack growth and stuff like that. And there's a float in there. But so this one amusement park ride, the one version that my customer had built, they were using 1-inch 1-inch fillet welds on 1 foot long on 3 foot centers. Okay, 1-inch fillet weld. So you had these gaps. Well, it's one of these flying cart kind of things where it's a big movie screen in front of you and your cart kind of moves 5 degrees here and there, but you feel like you're on some kind of spaceship or some mine car ride or something like that. So you feel really crazy, but it's only a 3-story elevator that your car's in with a big movie screen, but it was cracking out. And they're trying to hammer my customer on it, and they hired me in to support them. And it turned out the engineers had them feather out, you know how you cascade a stitch weld when it's a big stitch weld, you know, so it tapers.
It's feathered out so it tapers up to the high point.
Yeah. Well, they didn't like the look of that, so they had my fabricator grind the ends out so it was tapered down to paper thin. And then there's these elevators rattling around.
What could go wrong with that situation?
It just zippered, and of course it goes right along the heat affected zone. Well, it's going along the heat affected zone. You got a bad weld, you know, and nothing can survive going from paper thin to 1-inch fillet. You can, no way. And you know, we're halfway through the day, and all of a sudden I'm just coasting while they're all measuring everything and you got to drill holes in there. But the engineer, we can't do a finite element analysis. It's going to cost us too much money. I said, well, you better, because you've got unfixable welds here, you know. And I left it at that. And they said, I thought you were going to come up with something. I said, I did. Punch holes in the ends of your cracks so they'll stop running.
Yeah.
You know, that's about it. And put a weld pass in between those stitch welds. So a lot of diverse, crazy stuff, and maybe it's because I was stupid enough to stick my nose into it. I give welding procedures on these antique steels, like after the Northridge earthquake. Some of the old theaters in Hollywood were in distress because they were cracking out. Well, it's still just steel, and if we preheat it, we'll get, you know, it's just iron and steel, and 7018 is God's rod, so we should be able to make it work.
I'm stealing that.
You love it.
I love that.
Well, unfortunately, we don't weld with 7018 anymore, so you got to figure out a new one for wire, yo.
No, we're stuck on 7018 here in Florida, man. I talked to so many different contractors of like, have you guys thought about, you know, increasing weld productivity and deposition rate by switching over to flux core? And they're like,
maybe giving your folks a raise.
Yeah, they're like, nah. And I was like, so you like, you know, having a 60% efficiency rating on the work that you're putting out. You like to buy 100% of a product and throw 40% out in the trash.
Amen.
And then they start thinking about it, and it's like, you know, if you switch over to flux core, yeah, but the guys don't know how to run it. And I was like, you give me 10 minutes, I can show them how to run flux core. If they can run stick, they can run flux core.
I'm having to do it over the phone with some of these mechanic guys, and bless their heart, they're smart enough to know to listen. You know what I mean? So nobody's giving. Once we get introduced, they pay attention. But for some reason, people think, especially the on-the-job trained guys, the school trained guys don't have this problem, but they think that voltage is heat.
Yes.
They're constantly saying voltage is heat.
Turn my heat up, and then they go crank the volts up, and it's like, no. I don't need a wider puddle. I need a hotter puddle. Crank the wire feed speed up.
It's worse than that. It's worse than that. You get into where, and I actually had to go to the, an amusement park just 3 years ago, because somebody was welding, they were welding metal core, okay, but they had a one value only range, okay? It wasn't a range, it was just, you know, you're going to weld at 160 amps or some magic number like that. And the inspection agency found it, and they brought in a hot shot. I mean, this guy's well dialed in with AWS and professional engineer, metallurgist kind of stuff, and in the know. He knows all these folks at AWS, and he had the job shut down because he was claiming these folks were welding in the short circuiting transfer range. Well, what's happening is today's filler metal salesmen, they're peddling the hardwire to non-knowledgeable companies because it's inexpensive. And they're pushing them into globular transfer. Well, if you go to your books, even Lincoln in their gas metal arc welding manual, the pamphlet that they had, excellent pamphlet.
I pass them out to my students every term.
Amen. I taught out of it for years because it's really good and graphic. I'm with you 1,000%. And I still use it to wrap my head around things when I have to re-up. So, but Lincoln's gas metal arc welding manual, they just say globular is a mess. You don't screw around with globular. Well, I've actually qualified a test for a fire extinguisher company. Okay, they make the fire piping and stuff. And I said, I don't believe you can do it. But these shops down in southern Utah, they were doing it. And I'm, how do you keep from making a mess? And well, we're running 75-25 argon CO2, so it's not spattering the way that it used to. Oh, well, okay, but what's the bite like? What are you getting? I mean, I understand it, but you're going into short circuit every once. Well, no, we're not. Well, I think you are. And so it got into one of those kinds of things. Well, this inspection agency and their welding engineer caught on to it. And this is a big amusement park. I mean, internationally renowned amusement park. And this is an expansion. They got the job shut down for about a week. And so I'm in there representing the fabricator, and he's saying, well, tell me where the cutoff range is, where you go from short circuit to globular. And I laughed at him. I said, you know as well as I do, nobody can tell you that number. It doesn't exist. It's a sweet spot. It depends upon how old your machine is and how good your leads are. You're talking about a system, Dad. You got me in a rat's nest. Now let me turn it back on you. If they live with that one value, would they be in the spray transfer mode? Yeah, they would. Okay. Well, I'm sure their inspectors made sure that everybody had their machine set at that amp, that wire feed speed, and that volts. And so I can't see what you're worried about. And they had a couple of lack of fusions, but they weren't everywhere. But it was a fist fight because they're pushing in this globular range instead of just jacking it into full spray, which you can do with the metal cords, or running these pulse MIGs where you're doing it with solid wire and the machine's doing that work for you. And it's open arc all the time, or just weld it with flux cord, for crying out loud, and don't guess. But everybody likes the metal cord. Half the guys I know can't weld with it because they weld too slowly.
Oh no, metal cord, you got to scoot. You got to scoot, man.
Oh yeah.
It's fun playing with that stuff.
Well, I've one of my piping shops, I turned them on to the pulse MIG so that they could do it's like the pipeline, these Miller's got an MPA and Lincoln's got
the pipe workstation, and then yeah.
Well, they're all sisters. They do it differently, but I'm a welder. I don't care whether it's red, blue, or yellow. It's just a heat source for me that I got to dial in, but it's that kind of pipe work sort of thing where you can go in with a vert down route and then flip the switch and go in with
you can run like an STT and then switch over to a metal core filling cap.
And the one customer I had, because Lincoln has got they have one of the schools here, Davis Applied Technology College. It's a skills-based program, and Lincoln has their sales showroom at that school. And then Miller Electric, they've got one at Weber State University, which is our welding engineering school here in Utah, and well-renowned. So you go to Miller to show off the Miller stuff. And I know the lab rats, and so I just call them up. I had 2 customers who were they were changing their whole systems. And so I got to hang out with Rex Hardman once Miller's lab rat, and he's fantastic. And I got to train a little bit on this pipe works. It's a fun toy at 50 plus years old. You can still kind of see it, but I understand the programming. I can't weld fast enough to keep up with it. But my customer said they bid these particular joint in about 4 hours to fit and weld it out. Okay, it's 3/8 minus wall and stuff. So it's not monster welding, but the fit up and all that. They did it in front of the lab rat in an hour and a half. And that's why I'm talking about you Oklahoma dudes who think you're pipe fitters and you can't do it with wire, but you can do it with stick. I think you better go back to school, because you got to learn to do this wire stuff. I could be smoking a cigarette and joking by the time you guys are still trying to fit a 24-inch diameter can put together. I've seen the shootouts when they were first introducing the dual shield type wires, and they had a Lincoln lab rat come out, and we had Rocky Mountain Power gas line guys, and I'm sorry, it just didn't look pretty at all. Not pretty. So wire's the way you got to go to make production. And these pulsers are wonderful because you can get down to thin, you can run all kinds of different alloys on it, and you can tune it up so you're these AC sub arcs, my gosh almighty, you can tune it to where you're getting your more penetration and more fill, the trade-off between DC reverse, DC straight, and you're absolutely being able to see it in the weld itself.
I've seen that when they put in like the tandem 3, 4, and sometimes 5 heads, and then they'll stagger like the so sub-arc runs a little bit different, and correct me if I'm wrong, but like your DC positive wearing stick, that's for penetration. DC positive with sub-arc is going to give your penetration. DC negative is going to give your fill, and they'll alternate between positive, negative, throw an AC in there, and then repeat that positive and negative so you don't get any arc
remember,
flow.
AC is just DC straight, DC reverse flipping on a sine wave.
Right, it's flipping back and forth 60 times a
Okay,
second.
well, now all we've done is taken the AC, just like we did with the square wave TIGs, and just force it to hang a little bit longer on the DC reverse side. I'm thinking the TIGs to get a little bit more cleaning action, right?
Mm-hmm.
And I still get confused because I'm an advisor to the aluminum committee D1.2, and they've come up with they wanted to make arc control the penetration. They wanted to make it an essential variable. And I said, no, it's just, if you make it an essential variable, I got to inspect it. If I got to inspect it, it costs you more money to buy the product. And we've been living with this for 50 years without it having to be an essential variable. Maybe put it in your commentary so people know about it. But it's all, which side of the coin am I going to sit on? A little more DC negative, DC straight, or DC reverse, DC positive? And for some reason, what you're talking about, it's different for wire feeds than for TIG.
Mm-hmm.
Lincoln's got a pretty good cheat sheet if you go into their brochures and their support, their technical support, and they talk about the AC sub-arcs really good. But it's an AC. We're not running on DC current because it's flipping. It's just we're holding it for that microsecond over on the plus side or minus side. I have to have a book in front of me when I play this game. But it works, and I use it when I'm doing clads because I don't want a lot of pickup. So I want, like I said, before I had the control, I run short arc, and I tend to put the piece into vertical down. So it had almost, because I'm just tying together clad, and the clad doesn't have a structural value to the piece, it's just protecting it.
So you just want more build-up instead of less bite.
Yeah, you've stripped it back so that you got a carbon. I've got pictures of those joints if you ever need some, but so now you're just restoring the clad. So I didn't really care if I had lack of fusions. if they didn't catch it,
Mhm.
because you're not really doing NDE on the clad. You may be doing a dye pen to see that if there's any breaks in it, but we're not doing a volumetric inspection of it. So it had to stick. It had to be good. But if it had a little, eighth-inch lack of fusion, it was more money in my pocket because I wasn't going to blow the chemistry of that clad metal and have it destroy in service. You follow what you see? So pickup, penetration, these are all mystical art kind of things that we do have control over. But when we do design, when I need to know if something is going to stay up, I'm not worried about the penetration. Otherwise, I'd be telling you to use 60-10 on everything, or everything's got to be 70-18.
Right.
I can go through quarter-inch plate through solid quarter-inch plate with a 60-10 and still carry a bead on the back side. Maybe ugly, but I can do it. I figured some hot hand can do it and actually get a decent-looking bead. So I'm a little bit at odds with the state of the science, if you will. And there's a lot of art, and I play the art card quite a bit. And I think that's one of the reasons why I've been successful in repairs and why people come and ask me about how am I going to fix this? Oh God, I work for trucking companies who have to rebuild these pressure vessels once the trucks hit a bridge, okay, and they take the beach ball and they stretch it out and make it round and sound again. Some of the stuff is holding anhydrous ammonia. This stuff will kill you if it cracks and floods your car when you're behind them. I mean, these are life-threatening things, and it's not the traditional ASME welder welding on this stuff. These guys are mechanics. They may have torn apart race cars that wreck and gotten the driver back out on the road again, to finish the race. These folks are amazing, but they love machines. They don't love arcs and sparks. So they're pushing, going back to they don't understand the voltage. So they're pushing 23. I saw one guy put in 25 volts. I said, this can't even pass. And it's because they're still almost in the short circuiting range. They're not using 80% argon, which is a minimum you need to get a spray going for yourself. And that's only a recent thing that people knew in the last 20 years. I had people saying they were welding spray at 100% CO2. And you still see it in some of the sales literature, for crying out loud. I'm going, you boneheads.
Thank you.
Boneheads, give us something easy.
I get in arguments all the time with people that are like, oh, no, I spray with 75-25 all the time. No, your ass, you do. You don't. You got to hit 26 volts and 82% or higher in your argon concentration. Otherwise, it's not happening. It's gonna look similar, but, I mean, if you zoom down in there, that's not what's happening. You're not getting into a spray transfer.
Right. You got cold laps and
you're still not punching him, because with spray, you're going to punch in a lot harder than you are with short circuit. You're putting a smooth bead on top of that plate, but you're not punching into the throat.
No. And it's not supposed to. That 3/16 limit that AWS likes you to have is there for a reason.
Yeah, it's great for
It's
sheet
not
metal.
recognized by Aerospace, and I've gone over because I was pulled into Hill Air Force Base on an aluminum project for 6 weeks, and none of their machines were calibrated. Calibrate is a bad word because nobody calibrates.
Nobody counts.
Everybody's just checking. Okay, good man.
They're verifying.
They're verifying and checking.
I'm going to be fighting that soon with the doing an audit for an ATF, and that's one of the biggest things that I noticed. That I've talked to Dr. Rick Palanin on that, and everybody about the only way to calibrate a welding machine is you literally have to blow it up during the testing process.
I calibrated the analog gauges. I can do that.
Yeah.
But I've been fighting this because I had a $50,000 thread gauge catalog at the machine shop. We calibrated granite plates to 50 millionths of an inch with light. Okay. I mean, this is space shuttle stuff. This isn't, is my plate 10,000ths of an inch thin, or this isn't that kind of stuff. This is hardcore. You can't guess, you got to know. And I got to know out at 4 decimal places. Okay. On the headless pins that hold the space shuttle boosters together, we ground those at 4 decimal places. And the heat of your hand would make it grow, just carrying it from the lathe or the grinder to QC. We'd put it on one of these granite tables and we'd let it sit overnight so it'd come down to the 68 degrees that our inspection shop had to have, because aerospace, you have to have a known temperature they're measuring to, and then if you're actually at 70 degrees or 90 degrees, you do coefficient of thermal expansion to calculate what that growth was, just because you're up 20 degrees more than ambient. Okay. Mm-hmm. So these are fundamental things. It's metal heats when it expands when it's hot. It can get hot just up to 98 degrees. It's not 68 degrees. I'm 30 degrees higher. I'm going to have grown a couple of 10,000ths of an inch. Well, 10,000ths of an inch on a slip fit booster rocket that you're supposed to blow the pin out with an explosive, that matters. You don't want that thing falling apart. That's just kind because of a big deal. Rattling at 17,000 miles per hour. You know what I mean? So the sophistication is so marvelous, and to be able to run with that level of expertise and machinists who could do it. We used to pay the machinists overtime when we had no work in the shop, because we're all working, 60 hours a week normally, because even back then there weren't the skilled hands that we needed in industry to make it all happen. It's only gotten worse in these years, and so you just had to do it right, and you don't know unless you've checked your equipment. Going back to this calibration, we were calibrated. We did use tools 10% finer. If I had to measure an inch, I had to make sure that I was using something calibrated to an eighth of an inch. And my tape measures, if I was saying that it was good to a 16th of an inch, I had a machinist scale that I'd buy from Starrett for $75 instead of $15, because I could get the calibration sticker,
the paperwork
from Starrett.
With it. Yeah.
And now I had a mill standard calibration, a mill I-45-208. I think that's the old calibration. So it was true. Well, now that we're digitized and stuff, the only way you can calibrate it is if you can go back to the motherboard. And I have how to do that, but they don't tell you how to calibrate the standard that you're using to calibrate with. And Miller's got this, they've got their load cell that they use, and they won't tell you how they calibrate that. I suspect that they're using natural properties, just like the oxygen meters. You calibrate that by pushing the button, and it should say that you got 18% oxygen around you, because isn't that what's in the atmosphere, something like that? Mm-hmm. So you calibrate based upon the natural fundamental properties of nature, okay? And maybe by throwing X amount of current that you can measure through with a digital multimeter, then you're guaranteed to have this load cell. Or I don't know how to do it. I'm a welder, not a metrology guy. But you're absolutely right. And I've talked with John Gaylor at AWS, and he likes me as well. And I've got a line in the sand out there, because people use the word calibration indiscriminately at AWS, and I've had the opportunity to review a lot of standards and stuff like that. And when they use calibration, you can't say that, because and even American Institute of Steel Construction still uses it. And in the old days, we got points for quality. So you didn't have to do what the auditor said. You just had to have enough points to qualify. Well, at 250 welders and 300 welding machines, I was supposed to, I can't afford to have an inspector running around full time, just running around calibrating machines, or checking it with our load cell and stuff like that, to do something you can't adjust the gauge anyway. And so I'd look the auditor in the eyes and say, I'm not calibrating these things. We check them. We meet D11. We're checking these things, but we're not calibrating.
Yeah, we can verify
I've got to give you a corrective action. I said, fine, do it. And they'd just be dumbfounded. But in the old days, the company that you worked for defined quality. And if the old man wanted to run it into the ground, all of the codes will allow the old man to run into the ground, or old person. I'm sorry, I don't mean to be so sexist, but I'm old. I'm just talking that way. But most of the time, the old man wants the company to last because he's getting brownie points on the golf course saying, I built that building downtown and
Mm-hmm.
I'm feeding these mines. Nobody, even the 5-man shop that I got, a hand drill shop in Vegas who I got qualified for Clark County, Nevada, they had to inspect their own work. The superintendent was the quality manager. He owned the joint, for crying out loud. And there's, well, you got to have a separate department. I said, are you nuts? You're going to tell me that the owner is going to send out a bunch of dreck just because it fits his schedule? No, I ain't going to. However, in aerospace, okay, because we have had and in big league, like ballpark stuff that I felt, I have shipped out non-conforming product, and I have sold it, and I have had the not the customer, but somebody on the field raise Cain about it. We built this Bank One ballpark, the roof that went over it. I think it was we were building it, and we had a couple of light carrier beams, that they built the templates on the wrong side. It was upside down, but we had columns on this truck we were going to send out. So I'm not going to hold up a whole load of columns for 5 beams that are going to hold up air conditioners and stuff like that. So we wrote our non-compliance report, non-conformance report, put yellow tags on it, negotiated with the field. They were going to whack us $300, but at least it got their crews busy hanging columns, and so that the job's going.
Mm-hmm.
And so we're going to fix it. Well, receiving inspectors who are not us, but at the job site, they see these things coming in with yellow flags on it, and they start writing it faster can get the chains off the sucker, okay? And you're sending, and because it was a ballpark, the local news is there taking movies, video cams of everything coming off the trucks, and making sure nobody's cheating on taxpayer dollars or anything like this. They see these 5 baby, W12s floating through the air with yellow tags, shoddy product, substandard. We're gonna get killed with all this stuff. So I get written up, I'm going, wait a minute, I'm in control. I've got yellow tags. I got a non-conformance. I got an agreement with the field hands. You take your NCR and go throw it away. Give it back to the news people. I'm not taking this kind of crap from you guys. And that's kind of what you have to do when you're at a management level and you're paid to support the company. They're not going to be right all the time. But you got to if you're going to work for the man, you got to at least put the best foot forward on it. And I get these guys who, well, I have no authority. I can't do it. Well, build your authority, Charlie. You earn respect. It's not given, and not even as a welder.
Mm-hmm.
You got to lift some ladders for some old men before they start telling you the magic trick of striking an arc without getting porosity, So, but at the same time, you sometimes have to tell them where the bear is, and it's going to cost you money if you proceed any further, because the owner of the company can override my call. And that's the basis of quality management in the United States. The general contractors hire the inspection teams, not the engineers. In Europe, it's the engineers who are responsible for inspection. The AIs are independent, but that's ASME. That's not AWS and AISC structurals. So there's different subtleties to all these different quality programs that you kind of have to learn to live with. But the bottom line is, you're there if you got bad product going out and you're a quality manager, you better make some decisions on how to correct that. And it's your responsibility, because the boss is too busy getting new work in.
Mm-hmm.
I'm sorry, you can't command their attention 100%. And you better give them something they can make a decision on easy. So graphs, if you come to your quality meeting once a year, now that everybody's got one of those, just show the graph and say, our punchline, we fill a lot of holes. It's costing us a lot of money. I did that survey one time and found out the guy he chopped off the end of his tape one time. And so he was still using it anyway. It was too cheap to spend $15 for a tape. So we bought him a tape and didn't give him a raise. So it's that kind of stuff, and this calibration, you get people who are, I call them the bishops of quality, if you will. And, oh no, it's got to be this way. And then you start quizzing, well, what do you mean? How quality does it have to be? Is plus or minus 25% acceptable? Is plus or minus 1%? They typically won't have an answer to that, because supposedly a guy like me working for the old man is supposed to have thought about this before some auditor comes walking into my shop.
Mm-hmm.
And in the old days, I could lose points and say, we're not going to do it. And I've done this to Clark County, Nevada. They found some exposed electrodes that had rust on the ends, and they wanted a whole corrective action on how to fix this. And I said, we're not going to do that, because if it's a shoddy electrode like that, the welder's going to see that he's got porosity in his weld. He's not going to weld with that electrode. He's going to put it aside, grind out the porosity, and start a new bead.
Scrap
It
in the
costs
bin.
me $5.
Yeah.
It's going to cost me $20 to write the piece of paper, and another $50 to walk it through the system. Hopefully I've trained my welders to be the first line of inspection, and they're the ones who are going to care enough to tear out the weld, not having a guy like me saying, oh, you've got to take out that weld. And so I'm used to negotiating the quality. It's never one way. And as a fitter, you're taking everybody's mistakes and sticking them together to make it right at the end of the day. You may have to grind off a little corner there or gaposis over here or something like that. But you're always taking mistakes. It's nothing but mistakes in business. But the bottom line is quality is just the conformance to requirements. How I get there, what I have to do to get there, is nobody's business but me and the boss. That's why you came to us.
Mm-hmm.
You give me the design, I'll make the design, but you're not going to tell me how to do it. And an inspector's certainly not going to tell me how to do it. He can only tell me whether I'm right or wrong. Now, if you start getting into a trust situation and you trust me, maybe you're going to listen to me a little bit, but I'll sometimes smile and say, you're giving up your authority if you're depending upon me to tell you how to do it right, because I'm here for my customer, and I'm going to hose you to make sure that I'm getting what my customer's paying for. So we're all smiles, but you got to understand, I'm going to try and get a Cadillac for a VW price too if you start dicking around with this job.
Mm-hmm.
So, and I had one crucible just finished up about a month ago. It's a month-long crucible. It's taken them a year to get it. 3 stainless steel heads, inch thick, 7-foot diameter. Scrapped 2 of them before they even could buy one correctly. And I had to suffer through this with my customer because they went for low bid. And it's like, oh gosh. So those are the real worlds. That's kind of what my background is. And I got into being a production man and buying into the belief that we can do a good, quality, high-class job and meet the production schedules simply by planning and getting a team, which is hard to do, okay, pulled together so we're all got the same idea, instead of fighting back and forth on the floor, and seeing what you could get. I've worked with the guys who try to hide the weenie, as we say, and they always get caught. But they also move up the ladder because they're making production. It gets to be a grind.
Mm-hmm.
But c'est la vie. That's one of the reasons why I decided to leave welding engineering at Autoleave, because they were a factory, and the robots, and I work with folks. I like people, and I could tell them, just tilt your hand a little bit, get on the thick side, you won't burn through so much, or just try doing this one, you'll find it all glues together. Because again, I was a teacher. I am a certified welder. I still carry certs. Oh, can I tell you a story about I was listening to your show on with the Weld Zombie
Yes.
talking about big
Yeah, because we were talking
killer
about
weld?
that before we hit the record button. But yeah, I want to hear this.
Okay, so I'm listening to you guys. You're talking about that NR232 base flex that burns. I mean, I've worn the bandana and it just down the back of your throat. It just burns like crazy and stuff. But it is 7018 with the flux on the inside. It's ductile as all get out. It is the NR232, the NR233, the Hobart's course. They're all in the same um, group, that T8 electrodes. Okay, they are fantastic electrodes. They're ugly and they weld different. We're taught to kind of weld up like that for our vertical ups. Ironworks told me you do. Oh, so it's out there now.
Oh,
Good.
I
20
teach
years
it.
ago,
Oh yeah,
it's
yeah.
like,
You gotta
what?
point down into
What?
it.
I mean, even the Lincoln dogs couldn't figure out what was going on. And as such, because we're using it as a crucible now, like you're saying, ironworkers called it welding volcanic. And we just cranked the heat up, okay? And they have I taught at one of the ironworker seminars, okay? Because I did the FEMA, the D1.8 rat hole tests. I figured out how to do it for an international group so we kept our deposition rates high, and their contractors would be more conservative because they won't spend the extra money to do a high heat, low heat PQR, which you really should do if you're going to be doing big time steel erection.
Mm-hmm.
And so we always would have the ironworkers qualify at volcanic so that the contractors never get busted by low deposition rates, because that's a essential variable for welders welding D1.8 underneath the web of a beam to column connection, a moment connection. So anyway, so we're playing with this stuff, and this is the stuff I use to see why welds crack. Okay, so they gave me pounds of this stuff, so I got kind of used to running it, and the Lincoln guy said, "You can't, you're way out of procedure." And the ironworkers showed them, "No, we're just at the very top and a half a volt off of being at the very top." And you just fill up 2-foot joint, just one hand, one guy, king man, he could do it all. So so I wanted to take a weld test and go over to the hall, because everybody just gives me anything. I've been around long enough time. I wanted to learn how to machine one time, and one of the machinists said, "Bill, why do you want to learn to crank handles when anybody in this shop would do anything you wanted to them? Just give them the piece of metal to cut, and it's going to be much better than anything you could hog out." And so I kind of have taken that to light. And when I did my patent, for example, I just went to steel shops I worked with, because we were building the Le Rev Theater down and so a lot of the iron was coming out of Salt Lake City, going into Vegas for the Le Rev Theater. And one of my customers got shut down because they hadn't pulled together an erection plan to mitigate residual stress on these jumbo-shaped weldments, these W14 by 311 columns and beams. And so I came in to tell them how to build it so that they could reduce the triaxiality in it. Okay, so I knew there were companies with these monster beams. The dean of my department, he was my chair. He said, "So what did you do this summer?" I said, "Well, I built the Le Rev Theater, 160-ton frames. We built 5 of these things." And I got the job rolling again, and I learned some about triaxial stress. And he said, "Oh, that sounds cool. So now I know what your master's thesis is going to be." So that's how we wound up figuring out building a tub, pouring all this liquid nitrogen all over the beam for 4 hours, 6 hours, whoever was welding on it, you know what I mean? And holding the shrink tight until we welded all 18 pounds into the end, plus the web, until it was there. And then, of course, it's slow cooling, but we'd take the liquid nitrogen off, just bust open the box and let it evaporate out. And the beam would slowly grow out and push into the column. So it's just now I've gotten way off of where I was talking about. Sorry about that, Chase.
No, you're good.
I told you you're going to have to pay. But so the 232, so they give me the 1-inch plate backup bar, and Red sets it up for me, volcanic. Well, I don't get halfway up the plate when I've blown right through the 3/8 inch backup strip. Okay, and I freak out, and I stop. I said, "Holy cow! Give me another one, Red." And he laughs and throws it at me. Well, I down tune it down to well, I'm only going to put in 95 kilojoules. Red's putting in 105 kilojoules and stuff, and remember, in seismic, if you read the link inserts, they're holding you to 60 kilojoules or something down like that. Well, you're going to go broke welding down at that level. That comes out of an old Navy spec. And peace, another story, and better over drinks. So anyway, so now I've got it figured out. I've down tuned it a little bit from what the ironworkers have. So I've gotten in my root pass. I'm starting to carry it out. I'm getting to be happy. Well, I get it halfway filled up. Okay. And I blew through the test again, but it's out at the bevel. But now I've blown through a 1/2 inch thick of steel. Okay. And it's outside of the backup bar. But this time I remember this happens with 7018. Just hang in there. Hold.
That's the thing with that wire.
Hold, and then bang, I take off again, and I filled it up. Okay, so I'm feeling pretty good. Okay, even with the acid burns from the stinking flux and everything like that. But I did what I would have done if I had been a hot hand welder as a kid. And so Red goes to bend it. And if they see any flaw, they bend on the flaw because, again, they sit high in the saddle. So they can't monkey around. They got to test it the hardest way they can. And Red says, "What's this little hooner on the back side there?" And I go, "What hooner?" He says, "This one here." And it's where there's a little line, a little teardrop from my fill from the back out. Okay. I said, "I don't know. It's probably a mill flaw or something." I have no idea, Red, because you don't have to tell the inspector everything. I mean, come on. It works sometimes, but not all the time. So he bent it. It opened a little bit, but it was outside of the joint, and it didn't beat the 1/8 of an inch on it, even if he stacked it with whatever happened on my weld. So I passed it off and I go, "Got you, baby."
And nothing's more frustrating than because I did the same thing. I was in apprenticeship school for the Ironworkers 808 here in Orlando, and I already got my my A1 for the D11 3G 4G 1-inch test plate unlimited. And so they're like, "Okay, we're doing a lot of work out of the Cape. Why don't you try some of this XLR8 wire from Hobart?" And I was like, "I'll give it a shot. I never run it before." Get a couple passes in there. I'm feeling pretty froggy. I think come back to school like a week later. All right, let's go ahead and do this 1-inch test. I throw my root in there, all my fill passes. I'm working on my cover, and I think I was like probably the second pass in on my cover pass and blow a hole right through all the way out the backing strip, which doesn't make sense. But like now that I teach it, I understand it. I know more. You got to have that downward angle. You got to trust that it's going to stay there. If it starts digging, just stay in that hole or drop down a little bit. If you come up, it's going through. I got so mad, I took that test piece down, I threw it out the window, shut the machine off, and I was done for the night.
I bet you. I know exactly what you mean. Well, I'll tell you, ironworkers developed that technique. That was not being taught until they took it to the seminars, where the instructor seminars, where they bring the instructors in from all over U.S. and Canada. And Local Union 27 is really the ones who figured that one out, because they weld in this neighborhood. They weld hard. So it goes back to at these ironworker seminars, they bring brand new equipment, right? Because they want to see how it's going to be handled by roughnecks. They don't, it's not sitting in some little box somewhere. These things are slamming around. So they want to see if the suitcase welders are hard enough, the connections are any good, this kind of stuff. So all the experimental stuff, red, yellow, and blue are all bringing it to the ironworkers. and just to see how well it works. But those lab rats, they're also smart enough to know that iron workers and boiler makers and steam fitters, they're doing it 60 hours a week, and they're not just sitting with a little 6-inch test setup. They're having to reach around behind to figure out what they're. Thank goodness I can weld by braille, because I can't see it anymore, but I can still get it to stick. So that's the dialogue that you got to have. That kind of mentioned it with the out of school welding engineers. We've all gotten a couple of classes of how to strike an arc and what a bead should look like, and watching the horseshoe going up and stuff like that. But if you think that you're going to sit back in your office all day, you're missing half the fun. You got to get out there with your digital multimeter and see what's actually going on that circuit. And I was lucky enough at Autoleaf to even have a computerized fluke, so I could even see what the pulse programs were doing. You just blow it up because you're talking milliseconds, right? Mm-hmm. And I could expand out the screen, and I could see where boom, and see all my timers working out and all that stuff. I could see it in the program, but I'm timing it based upon, okay, I'm striking my arc. I need it to slobber about this long. Now I can take off on it. So I might have my travel speed program a little bit slower at the beginning and a little higher voltage so that I'm not going to stick, and let it get warm. And then it should be warm about, was that 0.3 of a second or 0.5 of a second? And it'll come to me, that's about 0.3 of a second. Now my windows my experimental window is down here instead of global, right? I got a 0.3, 0.5. Let me play within this timer here. But it's all based upon me striking an arc. How long, and working on a hot wire TIG where we're doing some of these clad overlays, and it may be out of position, some of these things. And so how long, the tech who's setting up my hot wire TIG, how long do you want it to dwell on the side? Just like a vert up, right? You dwell to take care of the corners, right? This thing's just like some monster movie, just shuttling back and forth. But how long do you pause? And I'd sit there going, I like a 2 count on that thing. Give me a 2 count. That's Mr. Machine. Mm-hmm. Keep it right in here and give me a 2 count. 2 count. Maybe give me a little angle if you can make sure go like that as we're going up. All the stuff we do by hand. How do you get it into the machine? Okay, and a lot of the robot guys, they don't have that sensitivity. Maybe they got 2 quarters at Ferris State or Weber State, or they got 2 quarters of stick and maybe a quarter of wire feed, but they don't get the chance to go in after hours and burn that rod till you get any good, and they haven't seen what happens. How do I get the sweet spot when my machine's gone into a dog machine? I haven't changed out the ground cable and it's all ratty and cut up, but the old man's not going to buy a new cable for me, so I still got to make it kind of look good. Reality checks, mm-hmm. Okay? And we're not talking about that in the nice textbooks. And you come out of school and you think, they're going to serve it to me on a silver platter. Get on the road, go work for somebody who cares.
Reality check. That's what I tell my students, because we were talking about base metal prep the other day, and I was like, should you take off the paint and the mill scale and the hydrocarbons and all that? Yes, you should. But if your employer says, we don't have time for that, go ahead and just turn it up 10 and burn that shit out, that's what you're going to do. So it depends on the type of shop that you're working for, the quality, program that they have built in place. Have I done it before in the field? Yes. That's what I was told to do. I was getting paid to do. I didn't know any better. But
right on.
If it says right there at the bottom of your prints, all welds shall conform to AWS D1.1 current edition, and you open that book up, we start talking about the fabrication section. It says that you're supposed to take off the paint and the mill scale and the hydrocarbons and all this other stuff. Do your base metal prep before you weld on it. But is that reality? No. Not everybody has time for that. There's certain jobs. You should. It's a best practice. Yeah. But not everybody's going to do it.
And it's a code requirement. If you're doing D1.1, as far as I'm concerned, you haven't done it, you're busted. Screw you. But there's like skip cars for mining cars, and they just want those things. Mm-hmm. And I had my foreman say the first pass burns off the paint and the second pass joins it together. So you got a 5/16 weld where a 3/16 weld would work, okay? Or like when I was teaching miners, this was Anaconda. Kennecott gets gold and copper from the top of the mountains here in Utah, but Anaconda goes down and gets the gold down at 3,000 feet and 2,000 feet underground. Okay, so they may be
Damn.
working right on top of each other, but at 3,000 feet, it's wet. And so there, maintenance guys got to repair the handrails. They got to, and they taught me, okay, we're gonna weld vert up, but we're gonna point down the first to blow off the lime scale from all the moisture here. We'll just make this garbage pass around, and then we'll come around with 6010 and we'll burn through that, because the 6010 wouldn't even go through the lime scale, the calcium deposits and stuff. So exactly what, and for maintenance, they're not welding to codes. Okay, their bosses won't tell them to weld the codes. The production people, the old man, aren't going to say, you got to make this repair weld to D11. You got to get that thing fixed because I need it in 2 hours.
Mm-hmm.
And one of my customers, big mine, they're self-insured. And so if a 12-inch steam line blows up, it's their pocket. They aren't worried about some combined life or somebody having to raise their prices or stuff. They make so much money off of the ore that they're pulling in, it's cheaper for them to pay for everything. The disability, all the horror stories that come with an accident. It's better for the company to pay for it and take care of the family their way than to get a third-party insurance company involved with it. Okay, and it's all legal. But you got to understand, I do lots of repairs. That because again, it's fun and it gives me a chance to think outside the box, and I get to teach folks how to sculpt stuff, especially non-welders, so everything's smooth. And we're removing raised metal because you're going to get a bad paint job, not because you're worried about the piece falling apart, but you're not giving your customer a classy job. They're buying a refurbished drilling rig. They want nice, clean paint on everything. You know what I'm saying. So I'm teaching guys how to dig out a groove that's nice. I'm way out of my league as an inspector, but I'm also working for myself, so it's my problem if I get sued. But also how to keep a bead smooth. Let's grind off this tip because it's just going to look like hell. You don't want it to look like Frankenstein. And try thinking about being Mr. Machines, because it's going to get wider at the top than at the bottom. Try figure that out as you go, pick up your speed as you go up. And let me show you how to goose it so that you don't have to use a runoff tab, because it's only a visual job anyway. It's not a X-ray job where you need zero defects. So if you goose it a couple of times while the crater's still red, pipe fitters have been doing that for years, with the helper there and, the handoff and all that. And I've been successful, but so long as it stayed red in my hood. Well, that was before the auto darkening hoods.
Mm-hmm.
Now it goes white, so I can't see if I'm looking at it. But so there's fudge factors in all of this stuff. And I get fantastic Sharpies, but I don't dare tell anybody how I do it. I've been making money telling people say, how come my 6061 aluminum test fails? I said, you're baking the weld. Get yourself the D1.2 aluminum code and look at section 5 there under fabrication. There's holding temperatures and times of temperatures for all of these 50 series, 60 series aluminums, 60 series aluminums that you can't hold it at 350 degrees for more than 10 minutes, okay? And otherwise it overages. I think that's what it's doing, but you lose all your strength. Okay, Magic Tony will say, well, you can weld for die pen or you can weld for strength, because we do a lot of fuel cylinders. They make propellant for these missiles and stuff. And so if stuff gets caught in a pinhole or something like that, it could blow up the whole system, okay? That's why they build the roofs to blow up instead of the walls, so that it blows up and out and doesn't blow out into the communities. So you can't have pinholes in aluminum. Well, as well as I do, it's a porosity son of a bitch. Aluminum is just like welding powder, okay? And welded with wire feed, you may have a nice skin, but aluminum holds hydrogen. So it's all in the middle of the joint. So as soon as you grind on that skin, you got Swiss cheese. Whereas steel, at least it comes out. And with steel, you got a chance of boiling out with your next pass. Aluminum, as soon as it gets hot, It hides in the molecules even further. You got to cut it out. Okay. You got to take that porosity out of there. And just, so really all it is, and I've learned this from experimentation, you can't just weld out the joint. You're only dealing with a little 8-inch by 10-inch or 7-inch coupon or whatever you got there, okay? And if you just weld, you've baked that thing like crazy. You got to throw a fan on that stuff and not call it quenching or cooling, because you're trying to mimic in 6 inches or 8 inches what you got a whole assembly you could be doing. Okay. And that's sucking heat everywhere, right? The heat travels in the aluminum. So you're up against a whole different fight. So weld your pass in there and take an eyeball, see if there's anything got to work on, and then hit it with some clean forced air. No, make sure you got dryers on it, because if it gets any moisture on it, the hydrogen goes into the weld metal as it gets hot, and you'll never get rid of it. And you'll have porosity, okay? Or you weld with strength, which means you don't weld it hot, you let it cool down so that it keeps it below that threshold, the holding temperature threshold, that they've done an excellent job in D1.2. It's one of the best things I've seen, and they did it about 10 years ago or maybe 15 years ago. It changed everything. Even Tony's got D1.2 now, and he's been welding aluminum forever. But he I've had him and the ironworkers. Ironworkers had to pick up some aluminum welding work because the Boilermakers they're in decline. There's not many out there, and so ironworkers are picking up nuke work out in Tennessee and Florida. I think they're doing Florida, but Tennessee, I know they had one there, because they're on there doing, working on the rig to hang a new ladder or staircase and stuff. So they're out in the nuke plants all the time. So the buyers are saying, you're here, you've already gone through all the safety stuff. Can you guys weld this pipe? Or can you, come on, it's going to save us a grundle. So ironworkers, again, they got to go through the whole training. They got to learn how to do it, because that's not their craft. Mm-hmm. But there's huge demand for it, because we don't have the old Boilermakers and steam fitters like we had 40 years ago, okay? And so the ironworkers are stepping up. But I remember when I was teaching, the day shift guys would say, ironworkers can't weld aluminum. Don't teach them how to weld aluminum. I'm going, ironworkers are welders. They want to learn everything I have to teach them. So what the hell? I'm night shift. I'm going to keep doing what I'm doing. I just won't tell you about it.
Yeah. Just keep that part out of the syllabus.
Kind of so baking your test coupon is a big problem, and people fail it right and left. And all I can say is walk away. Just let her cool down. If that's what it is, run it past and walk away, or throw a fan on it. And I've got pictures of when we did a 8-inch aluminum pipe when we wanted to do pulsar. And so I think we did a TIG root, and then we were going to cap it out with the pulsar. Okay, because there was something, it's about 10 years ago I did this, but the union guys just outran me. They just, iron worker, I hired Tony because he was a union pipe fitter. So I figured I have brothers teaching brothers, you know what I mean? So there's that going on. Well, they got into, we know what we're doing. This engineer, he ain't for shit. So but guys, you gotta let it cool down. Yeah. And they're smoking and joking and doing all this stuff. And okay, I get paid by the mile. Screw you guys. Just run her on out. Looks real pretty from here. Yeah, no, you guys are doing great. We go to test it, and it snaps. It should be breaking at 24,000 PSI for 6061 T6. And it's down at 18 because, pulsars are hot and stuff like that. And I said to him, and I ran it as a quiz because Red's an instructor and stuff. So what are you going to do to make this right? And he said, well, I called up one of the weld supplies houses, and they said I should have used the 5053. And I said, you're going to go broke with your program. You only need 4043 for this stuff, 5356, pardon me. And what does the sales guy know anyway? These molecules going to jump into the base metal to protect it from cracking? I mean, well, what, So I said, you burned up the plate, guys. And so that got him thinking. Magic Tony he made a copper coil because we would seal off the ends of the pipe, right, with masking tape and cardboard, to hold the purge gas in there because we were still thin we wanted to make sure that we didn't screw up the bead on the inside the TIG bead. And so he built a copper coil and a carbon steel shoe. There was a 3-inch trailing gas shoe that we built for the inside. And so, but the copper would kept us a cold shielding gas going into the inside to protect the root side of it. Okay. And so then we'd have to rotate it. So we'd rotate it like 4 times around. There was just enough time with the cool gas to cool it down. But we had 4-inch thick stainless steel piece cut out in a half shell that we put right on the weld to suck heat out. Tony's all about heat sinks with aluminum. I got red there once she kind of got cooled down to get it down to room temperature with a fan on this sucker. He's just cracking up. He can't believe we're throwing welded out. Tons of strength. We beat the 24,000 PSI min and stuff like that. Dynamite welding procedure. But at the end of the day, I said, I can't do this job without you, but you can't do this job without me, sucker. Point of respect back and forth on that one. So it's a fun deal.
Okay, next I want to talk about your work on the Mars rover, but first we got to take a quick commercial break. This segment is brought to you by Strong Hand Tools. You can check out their products at stronghandtools.com/ArcJunkies. Strong Hand has some great products out there regardless of your budget. Their tools are designed to make your welding and fabrication projects easier and your shop time safer. Whether it's clamps and magnets for holding materials in place, their bottle carriers and accessories to make transporting bottles a breeze, or their fab tables to increase your accuracy, they have it all. Check them out at stronghandtools.com/ArcJunkies. We're also brought to you by AHP Welders. If you're a tinkerer, a hobbyist, or a student on a budget, AHP makes some great machines to get you up and running to build, make, or practice at a fraction of the cost of other machines on the market. I've used several of the AHP products in the past, and for the price and performance, they can't be beat. Check them out today at ahpwelds.com. And now, let's get back into the show. So tell me about the cool thing, the most recent project that you did. You've got a weld that's actually going to land on the surface of Mars February 18th, which when this episode comes out, it'll be this Thursday. So on Perseverance, you got a piece.
See if I'm all talk or no action. There's nothing like a destructive test to show if your work is any good, huh?
Right.
I didn't know it was landing, so you got me just in the nick of time. This is going to be the telltale, Chase. I'm loving it. Yeah. Like I said, we do a lot of aerospace out of here. Okay, lots. We got Northrop Grumman, we got Boeing, we got ATK Grumman up doing the space shuttle. We're not doing SpaceX, but you guys aren't the only ones to have a good time. So one of my customers I've been working with for a number of years, they make a synthetic fuel, and they have machines that will generate more power. They're like inverters. They generate more power than they take to make the power, okay? And these welds are holding, I can't get too deep into it, but it's the way the circuit goes through to change the molecules to make it a fuel instead of just whatever it is they slog in there, some kind of oil or something, but it's self-regenerating. But it's the MOXIE program, MOXIE. And the experiment is to pull oxygen out of the Martian atmosphere in hopes that we could put a lab up there, and this experiment would go into production and pull air to feed the laboratories that would be stationed on Mars. So it's in the belly of the Mars rover. I actually got a chance to see somebody I met was in the Lawrence Livermore Jet Propulsion Laboratories, JPL, Jet Propulsion Laboratory. But he said, I'm an education manager. And he punches it in. He says, your weld is right in here. He shows it to me. Got one of the cameras at the laboratory to show me the MOXIE experiment. And of course, it's just a jumble of wires and metal and stuff like that. But no, your stuff is, I've been looking at that for 6 months now. I didn't know it was you, that kind of stuff. So, but and I gave you pictures, and I don't know if you want to play the share screen or what do you want to do?
Oh, go ahead. Yeah, I'd like to see some more of it. I've got the pictures that you posted. I'll actually put on the Instagram release.
It's an ugly view, but here's a weld symbol for a flare bevel groove, right?
Mm-hmm.
This is a pin. Oh gosh, when well, starting from right to left, you got a pin with a D that's a diameter. That diameter is only about 3/16 of an inch diameter, okay? The wire is 0.03. It's smaller than most hard wire, short arc wires, right? But the wire itself is Inconel. The pin is called ITM. It's man-made material. It's powder metallurgy where they heat it. It's sintered and then pressed into a piece. Okay, and then the flat piece there that the pin is in is actually a ceramic. So the square or the rectangle on the far left, that's a ceramic block that's got circuitry put into it because it's an electrical device. Okay, and the circuits are they're etched into the ceramic, and the pin, the D, it is actually brazed into the ceramic. And there's like 3 of these stacked on. And the wire that you see there, that's being welded to the pin, it's just the only reason why we really had to put a weld on it at all is because when the Perseverance lands on Mars, the last 30 feet is a drop. It's like it's being dropped just out of the sky from 30 feet. So the wire has to stay on there or the experiment fails. That's what puts it as a D17.1 Class B weld, is that if that particular joint fails, the experiment can't work. And that's what Class B definition is if it's not failure of mission, but it could be failure of an experiment or failure of a system that is important to the mission. It's not Class A, but it's Class B welds. Okay.
So this is like a mission critical component. It's not like a door latch on the outhouse.
It's an experiment critical component.
Okay.
If the experiment fails, nobody's going to die. Okay. Class A, it's failure of mission or life.
Okay.
These are the experiments. It's like if my chair didn't work, I need to have a chair when the rocket goes off, but I probably can figure out something else to do, just like a sci-fi movie or something. So this is classified category B weld. And that little weld, it's only 60 degrees around the pin. So we're spending all this talking about an 1/8 inch TIG weld, okay? I mean, but it's all like one guy went in when we did whoops, and the inspectors were ripping us up on stairways for a little undercut here or something like that. It's kind of almighty. When did you ever hear about a massive leak in a nuclear reactor because of an undercut in a handrail? And he says, I don't know. I don't see anything in the code that says I have to look at a nuclear reactor any different than a stair stringer, or stringers are not structural steel, but the image. I look at a structural beam the same way as I look at a nuclear reactor. It's all per code compliance to requirements. So they're not saying inspect a handrail differently than the column.
Right.
You just got to inspect it. So this tiny little TIG weld goes through the same hoops as though you were a pressure vessel with a full pen weld that had to hold 2,000 PSI or something, which is what our welds had to hold on that nuclear bomb simulator, on those 197-foot pressure vessels. They were tested at 2,000 PSI. So that's another story. Let me go back to Mars. We had a 4-inch blind flange crack on us on that one. It taught us a lesson.
Mhm.
But anyhow, so on to this thing. So it's important, but the weld procedure itself is simple. And our customer wanted to TIG welded because it would give him control of his schedule. The JPL wanted to electron beam weld it because they wanted to do that. Yeah, I guess there had a little bit to do with the heat input. Are we going to burn out the brazement, right?
Mhm.
Because braze is less than the 10,000 degree arc I'm going to have and the 3,800 degrees I need to have to melt Inconel or whatever the heck it is. So I can go to books, it's not Incolloy, but Select Arc is, I think it's Select Arc now makes all of our Inconel filler metals and stuff like that.
Really?
Yeah, well, I'm sure there's I'm sure there's others, but Inconel was their name for high nickel alloys.
Okay.
Okay,
I was just wondering
and
because I've ran a lot of the Select Arc stuff, man. I love their wire. All their flux core stuff is awesome.
well, aren't they the stainless my books just
That
sitting
might be
over
that
in
might
there,
be
and I use their book all the
Sandvik.
time.
Sandvik?
Now, it's not. I got Sandvik. I've got everybody's.
Okay.
I wouldn't have a job if I hadn't taken all the welding brochures I've ever been given. I've, I've, I've got a lot. I've got stuff going back to the 80s when they used to tell you how to do stuff before liabilities became a big deal and everybody stopped telling you what to do. They just said, this is optimum. We used to get full brackets, don't go beyond this, don't go beyond that back in the 80s. So I've got a lot of it. That's how I became a welding engineer. Like I said, I've never gone to school for a welding engineer. I've gone to school for metallurgy and metallurgical engineering because when I went back for my master's or my first degree in engineering, my master's, they made me take a lot of metallurgical engineering classes because they'd never had a welder in the civil engineering program before, and they tailored and at my age because they had profs younger than me when I went back to school. They tailored it for me, and so I've got 5 hours at 5 classes and 6 and 7,000 hour level metallurgy classes. So they asked us, so what do you want us to teach? I said, I want you to learn how to heat treat steel. And the prof said, we haven't worried about that in 40 years. I said, I know, you've outrun the industry. You guys are all into mnemonic memory metals and stuff like that. And we've got people who can't stress relieve anymore. They don't know how to do it. We've got heat treaters who can't keep thermocouples on pieces and stuff. I know I've seen pieces melt down in heat treat ovens before. And I had a heat treat oven that was 20 by 20 by 120 foot long. We do whole major pressure vessels. We'd stress relieve them in this furnace. And so I know how they work, and I know how you got to futz and fix in order to get it to be a good job. Everything's a hard job. There's nothing easy.
Mm-hmm.
So the heat input was a big deal for us on this, and it actually shows up in the picture. But this is what it looks like, and it's a flare bevel groove. It was easy to find out because they gave me the mill test reports, or not mill test reports, but chemistries on this pin. And like I said, the pin was about 26 or 30% chromium with no nickel in it. Okay. Yeah, I got to look in front of me. Yeah, 26%. And these ferritic stainlesses like this, they almost have no nickel in them. It's almost, if there is any, it's a tramp element almost. And the rest of it's iron. Okay, just so it's an iron chrome ferritic stainless steel. So, and then my wire was Inconel 600. So I can go to the I'm going to say Select Arc, but God, I hope I'm right because they've got great great handouts to use, and their catalogs are wonderful. And they say, oh, use filler metal 82. Well, you weld everything with filler metal 82. It's like silly putty. It sticks everything together. It's 68, 70% nickel. So it's stretched forever. It just goes everywhere. It's wonderful. Okay. Um, we use it like some of these hot rod guys who, instead of using 4340, which can crack pretty easy, even with a good heat treat, they'll sometimes use a 312 stainless steel because it's heat treatable as well as stretchable. And so on a front end, you want a little bit of a give on that steering assembly, right? As it's bouncing along the road. So this stuff can handle the impact without cracking out on you over time. These particular high nickel alloys, and so they're wonderful tools. We often will weld as an alternate to that ferritic stainless to carbon steel flange that cracks out all the time for my customer. If we welded with the Inconel filler metal 82, it would never crack. It'd stay right in there because it's not affected by cycling heating. It doesn't like magnesium. The magnesium, it eat every piece of nickel out of there. And one of these days, I'll show you a groove that shows that just perfectly. So the welding, what am I going to use to weld it with? That was a piece of cake. And that's what a lot of people think a welding engineer has to do, okay? It's just, what do I stick it together with? What process do I use? Well, the process was controlled by my customer because he wanted it TIG welded so that he could keep his production going. He didn't want to get lost down in California and somebody at shipping saying, well, they don't need it right now. I'll get it to them when I give it to them. And of course, we have Magic Tony up here who can weld glass to any, he's astounding. So, and my customer knew Tony. And so Tony was going to do the work. Tony bought a brand new little TIG machine. We checked it, didn't calibrate it. We checked it, did everything right. But the problem is the groove design. You notice that they're telling us to use a flare bevel groove. The only code that addresses flare bevel grooves really is D1.1. And they just give you the formula over in figure, what is it now? Is it 3.1? 3.2 now is the partial joint penetrations. And at the very back of the partial joint penetrations, they got flare bevel and flare V. And D11 gives you a formula for calculating, as an engineer, for calculating the strength of that weld. Okay, and the weld size is going to be 5/16 of twice the thickness of the base metal, okay, or the thickness of the tube steel, for example. I'm going to find another picture here. This one is it's a photomicrograph of the piece itself. Let's see if I can shrink that down so you can see it. Now, so I'm going to expand it just a tad. I'm not doing as good a job as I'd like, but this is a photomicrograph. I think we're at about 100 magnification. And the reason why I had to do the photomicrograph is because, come on, give me one shape here. Let's get this guy, and I'll go with this guy, and I'll go with this guy. And if I'm lucky, there we go. So this here is the wire. That's 30 thousandths diameter, okay? And it's Inconel. You see, can you kind of see what I'm weaving around? It's the piece on the left, okay, that says wire. Okay. The thing in the middle here is filler metal. That's the Inconel. This piece here with almost no detail on it, this is the base material of this sintered rod, okay, this ITM rod, okay? Now, because I said earlier it's ferritic stainless, it's 26% chromium. Well, it's virtually all, boy, am I going to get caught now. It's all ferrite, okay? There's no nickel in here. Nickel is what they call an austenitizer, and it'll start making austenite grain structures, okay? And in normal carbon steel, we'll have some kind of matrix, and it'll look like leaves, if you will, of the perlite, for example. You've seen the mock-ups of perlite where it's austenite on top of ferrite on top of, it's cementite on top of ferrite on top of cementite. Well, the austenite will act as a shock absorber in the joint design as well, but you need some ferrite so it doesn't hot crack on you. Well, you can see you got no austenite in this. The austenite, the nickel, is what's showing up in these brown colors in the pictures. So this wire being an Inconel, it's got a lot of nickel in it, and that's why we see the wavy lines through it. This filler metal is at least 68% nickel. That's why we have all those brown specks in there. This is almost all chromium and iron, so it's not tinting with the tints that we use to check the austenite. Does that make sense? And I should have studied a little bit more. I'm hoping not to be like some of these lawyers I've been seeing on TV, but I think I'm being a little accurate on this. But you see here in the middle of the box, we got no fusion, right?
Mm-hmm.
It's just open. We almost start, you can see the lack of fusions here in my cross X, okay? And here it's wide open. So the question is, number one, how do you qualify this thing? Because when you qualify a joint to D17.1, you have to do a pull test on it. Well, how do you pull test that flare bevel groove, right? This picture, see if I can call her back up again. No. How do you qualify something that's still wrapped around? There's nothing to pull, right?
Mm-hmm.
You need 4 inches on, or do a micro specimen, but you need to do an axial pull, which means it's an even pull on both sides. You can't lay it like this. Am I getting my camera right? And pull on it, because it's putting a bending moment in it. It has to be.
It's gonna be a straight inline pull.
Up and down. And I've seen guys cheat in the inspection and try and test these kinds of things, and they force this and they get a crack, and now they're looking at grain structures and stuff that's not in D1.4, for example, which is where that experiment came from. So there's tricks in how you test stuff that you got to watch this all every minute, okay? So the question is, how do I test this per D17.1? I can't put a pull test on it. The joint isn't even recognized. They say, if you got something special, work it out with your engineer. Well, as we said before, most engineers are skitterish about listening to a fabricator. We're all lying sons of bitches and just trying to screw everybody so we make more money. Well, so I have to come to these engineers with an idea that at least makes some sense if I'm going to get them to buy into it. I can't just say, well, I can't test it. It can't be done, so give us a hall pass. Mm-hmm. I got to give them something, because it's their liability out there. They're paying lots of money to be aerospace engineers. So the big concern is, how do I know the actual weld size of that weld? Because as we saw before on this guy, and by definition, a flare bevel groove is from the tangent point kind of out at the very far end of the radius to the bottom of the joint. But because we can't see the bottom of the joint, the code writers won't deal with it, because they cannot guarantee that you actually got the weld size. There's no way to see it because it's buried under all this metal, right? And we know by looking at the tables of partial joint penetrations, and they've got tables in D11 that say the minimum weld size for a 1/2-inch tube steel has got to be what? A 1/4 inch or something like that. And they translate that even into minimum in clause, the fabrication clause. I think it's 5.
Yeah, it was 5 in 2010.
Yeah.
I think it changed in
I should be
2020.
talking 2020.
Yeah,
So
I just got the book last week, so I feel you on that one.
Yeah, well, I reviewed 2020. And I'm also talking to you. I should be accurate. So I think it's going to be clause 6 in one of the tables in the back there. But as an inspector, I can't see the root of a flare bevel groove. I can't tell you the size. And I've seen some of these things fail. And so if the welder's riding on his puddle and not keeping the arc out in front of at the crack of the joint connection, the interface, they're insulating. They're not getting down to the root of that weld down in here. You know what I'm saying? So aerospace code, aluminum code. I've been even seeing the experiments that they're trying to run in aluminum to try and be able to quantify how deep a penetration you're getting with that. And I pop in and say, well, what if the guy rides this puddle? He's insulated. He's not penetrating down deep at all, like we run into, say, rebar for the indirect butt joint qualifications. You're never going to know. But hopefully it's going to be over welded. It'll be a little taller, on the fillet side or something like that. Or we're going to go with the fact that most of our 70 class electrodes now are all 80 class. They've been jacked up the strength of the wires for the automotive industry and to protect us after the Northridge earthquake. So our 70 class wires, you start doing your pull test, you're sitting at 81, 83 thou. I've used that to push marginal jobs through to engineers, when they've missed a stretch, they've specified a shape that doesn't exist. So I have to build it from scratch out of channel irons or something. And the one engineer said, oh, you're giving me an 836 channel iron. That's not going to be as strong as what the 50 KSI I'm specifying. I said, you told me a tube steel. That tube steel's down at 49 KSI or 49,000 pounds per square inch. I'm giving you a channel iron that's over 50,000 square, and I bet you we'll come in at 55,000 pounds per square inch when we're finished. Okay, I guess I have to take it. I said, good.
Good, I wasn't
I
giving you
can't
a
wave
choice. I'm just
around
letting
for
you know
you
what I'm
hemming and
doing.
hawing,
Yeah.
I know that I'm going to get a cert no matter what channel iron. Today's, I'm going to get 50 class material. They don't have, when they're building some of these buckling restrained braces for seismic, they have to order A36 special in order to get a material that is stretched at only 36,000 pounds per square inch yield instead of the 50,000 pounds specified by A572 grade 50 at A992, the wide flange and structural shapes spec. So yeah, if you know your materials and you've watched your fluke meters and stuff, you got a better idea of where your tolerances are so that you can present them as in front of engineering groups so they can make reasonable calls and support your production levels instead of just, well, you're the boss, you tell me whether I can do it or not. Everybody's got to be engaged. Everybody's got to be engaged. So it's this little spot of lack of fusion that they haven't been able to figure out. That is why engineers are afraid of the flare bevel or the flare V, where both pieces are radiused, right?
Mm-hmm. Isn't that kind of similar to like a TYK connection where you've got a Z loss and you kind of accept that fact? So you just oversize the fillet, the depth that you're going to lose.
Well, it's not a fillet. Remember, these are all groove welds.
Right.
Okay, they're class. I look at them as fillets, and if you read the AISC steel construction manual, if your radius is less than, I think, 1/16 of an inch or something, they call it a fillet. The AWS doesn't call it that, but if you use the structural design code as part of your inspection criteria, because the project specs are going to say weld to D11, but they're going to say build to AISC 340, I think is the steel construction specification, how to build structural steel. And so you really, as an inspector, should be looking with both codes. And sometimes they conflict, in which case the structural engineering code supersedes AWS. And I catch a lot of inspectors who don't know that. They only read D11, and AISC takes exception to several sections in AWS, like the roughness of cuts and stuff like that. But we're a volunteer organization and everything's consensus based at AWS. So we have to negotiate and we have to compromise back and forth. And not everybody comes to the table with the same skill set. I can't expect a filler metal scientist to understand the thing I have to do to weld to make their filler metal flow. But on the same token, I don't understand how they're what they're doing with this with these T651s. They stretch it, are they stress relieving it? Are they getting more strength by kind of locally work hardening it? So there's subtleties there. I just have to, it's out of my league, and I'll vote abstain on some of these things because I'm a dominant character fabrication and welding, but you get into some of the molecular this and that, it's over my head. We all have limits. I'm happy to say that. And so this Z loss factor, and I think that's as good a description as any because we see it in the TKYs. Okay, it's the same deal, but the welder has a lot to do with it. So that's a number one problem. How do I qualify this joint? Because I'm supposed to do pull tests on it per code. The second thing is, how do I qualify a non-existent material? Something that only exists because the scientists have figured out they can make stainless powder, chromium-rich powder, and if they heat it and press it, it turns into something like this that is stable. It doesn't change very much with heat because there's not a lot going involved with it metallurgically. It's really just iron and chromium and maybe a couple of magic Colombian vanadiums or something to keep everybody happy in the molecular structure. You know what I mean? Again, I don't get wrapped up with the metallurgical science. I'm more in how things stick together. So how do I qualify a non-existent material? Well, you read up on it. There's not a whole lot of information out on there on how to weld ITM, and I don't even know what ITM stands for. I apologize again, but I'm more welder than that. And there's a lot of art in my work, okay? And so so I was reading stuff coming out of universities because you can get into some of the university libraries. And if I Googled ITM, I got into some of these. University of Pennsylvania, they're a real good school. The welding TWI out of England had some stuff, okay? And basically, they basically said you might be afraid of porosity. And we can actually see some porosity over here, if you will, inside of this piece, okay? Not very much. But because it's ITM, we don't have a whole lot of material to experiment with. I was given a couple of square chunks. That's what this stuff was. It was square, whereas in production, they ran some round pins. But we started off with square, and I only had like 3 inches here, and I had to make an axial test, right? So I cut off about 2 1/2 inches and had Tony weld a piece of this Inconel wire on with just fillet welds. So it's really just heated up a gobbin and jammed the wire in there, right? Because it's only 30 thousandths. I mean, it's like welding on expanded metal, or it blows away. So I put it into the tensile machine and pulled, and it snapped the wire. It snapped it up close to the weld, which, okay, so I got some geometry problems going on there, but I still hit over 100,000 pounds tensile, okay? And I didn't pull a slug out of the piece of the ITM, the ferritic stainless, which was what I was afraid of. So if I didn't pull out, then that material is pretty weldable. So now, how do I figure out how to test this sucker? So we go back to there's no test coupons in D11, in D17, in B2.1, which is our go-to for any other welding procedure, welder qualification, right? I've qualified armor plate to B2.1 before, okay? So you can do anything with B2.1. It's very similar to ASME. But hang on, I'll get back to my mind on this. So I have to figure out how to get a test coupon to where I can pull on the weld wire in a uniform axial unidirectional load. So I'm not putting an obscure load force on it or anything. It's just straight up and down. Devo land. It's never straight up and down except when it's an axial test. Okay. It's mandatory. So I just scratching my head. And of course, there's nobody you can ask about it because nobody is that deep into this stuff. And I went back to the iron workers. We qualified all kinds of indirect butt joints. Number 14 bars, have a number 4 bars for the welders, and all just tons of rebar back because the inspectors were just figuring out how to inspect rebar. And what used to be okay, guys just weld rebar with whatever rod they had kicking around. All of a sudden, you needed welding procedures and qualified welders. And of course, the ironworkers, the first folks getting nailed on this stuff. So I figure it out for them, and I wind up making money for the next 5 years from all the non-union craft coming around getting ripped up, trying to figure out how to qualify rebar, because you have to qualify everything in rebar except an anchor weld, the T-joint fillet weld for an anchor, if you will.
Mm-hmm.
The indirect butt joint it tests in shear. You've put your plates to your rods together. And so it winds up looking just about like this, okay? But it's thick, it's visible. You can actually see it. So I got 2 of the pins and put them together as though they were the outside rebar. And then I put the wire in between these. There were 2 pins on each end, okay? So that it gave the tensile machine something to grip. And then I welded wires in the flare V groove on one side and then on the back side. So I had 2 wires going. So now the machine could pull. The problem is with the wire, you can't get it taut to begin with. So one wire is a little bit tighter than the other. And so consequently, there was a little bit of catch up, but once the other side caught on, it started pulling against these little tiny welds. And finally she broke right in the middle of the wire. I had 110,000 pounds per square inch. Once you calculate it for a 30 thousandths diameter wire, I knew I had a winner. But I'm going, why aren't these other people figuring out? I can go back to D1.4. D1. Rebar is some of the dirtiest metal you ever seen. On the old A615, you could still see the threads from the old axles that they chopped.
It's all the old Volkswagens you've been trying to buy.
Yeah, no, you just preheat the heck out of it because it's the carbon equivalent is up there around 50 or 60. You can't believe it's going to stick. But again, a nice low hydrogen rod, and for you can sometime for an indirect butt, you can often even just use a 70 class if you're using an angle iron for your splice strip, because you're not going to get full strength out of that. It's going to be your angle iron or your plate, whatever you've used to set the butt joint on. That's your weakest spot. So you could weld with a 70 class electrode all day. It's only when you got a square butt joint that you're really going to generate the strength of the base metal, for a pull test. So I'm just thinking to myself, my gosh almighty, I've gone back to one of the most basic, unsophisticated weld materials, weld base metals, and just the grunt code, right? I mean, it's all going to be stuck in concrete anyway. No, you don't even get to look at your welds to figure out how good a welder you are. It just gets dumped into the mud and it's done. And I'm going, but here I am using D1.4 in order to justify a good weld, but because the code doesn't describe this particular joint configuration, I have to pull it and then write a little masterpiece on why this is a valid axial test to test the shear strength of these wires as they go into tension. Because this is a shear. These aren't full pen tests, right? Mm-hmm. You're like a fillet weld. The fillet weld is a shear. And we don't test fillet welds to test the strength. We just beat them over to see if there's discontinuities in there, right? Sheet metal, same thing. None of our sheet metal tests are we tested for strength because they're so ductile. You're not going to get a valid strength test out of it anyway. We just beat it apart to see if we got discontinuities and if our arc spot weld diameter is as big as it's supposed to be. So that is really what I wanted to get at, is that get your head out of the damn code. The code is just the minimum requirements. And if you're going to make the job for your company and you're going to be good, you better have your thinking cap all the time and use your art and extrapolate. That's the bad word for a lot of engineers and inspectors. But I'm always out of the box. I've always qualified by procedures at high heat, low heat ranges. I spin the dial, so I maximize my welding procedures for my company, or my customer, or the company I'm working for. I'm talking to guys, this is where you want to put your heat. I've got a new way of joining trusses together because I work in the temper bead with ASME, where we're getting rid of post-weld heat treat for some P4 chromoly tanks, simply by putting an extra bead on, or 2 extra beads, and measuring where we aren't going to come to the toe, but we're going to be maybe up to a 1/16 of an inch from the toe of the weld. And then we grind it all off. So we have to grind off that fillet weld to the proper size after we've stress relieved it with a weld bead.
So you did
I brought
something
that
similar.
into structural engineering, and it blew their mind because they thought all the beads had the same strength. Well, no, each bead's been tempered by the bead put on top of it.
Yeah.
I've stress relieved every bead. That's why we're really only worried about, on thick sections, the toe of the last passes. What they haven't told you is every bead underneath is stress relieved the bead underneath that.
I seen you did that technique on the driver tubes.
Well, it wasn't. No, actually, it's for the trucking company, because
Okay.
the trucking companies, they're on minimum profit margins. Okay, the only worst is probably structural steel shops. Structural steel shops may be working at an 8 to 10% profit margin. You know what I mean? It's a tough business. You got to be smart to make money in it, and we need those shops. Well, the guys who are fixing tanker trucks that have hit the bridges and stuff like that, it's one of those jobs where, well, hell, you better be cheap enough for me to take it to you, because I'll just buy a new trailer. You follow what I mean?
Mm-hmm.
So there's a definite ceiling about what the market will bear. Okay, so that controls how much expertise can you bring to the table. Well, they found me, and we've worked together in some of these mining repair outfits. They found me. I don't know how, because I don't have a sales force. People just call me up. But I'm telling them, you got to watch about your weld profiles. And if you can see you got a pinhole there, just fill the sucker up, because you got paint. It's going to make it look like hell for the paint and stuff. But these chromolys, some of the NDE houses also do post-weld heat treating, right? And they do a great job, okay? But I know it cost me $1,800 just to fire up my big stress relieving oven, and some of these NDE houses are doing it just to show up, and these things are made. The tankers are made out of 1/4-inch plate, so it's a quarter of an hour stress relief cycle, half an hour stress relief cycle. Give them a half a day to set up and break down, you know what I mean? And they're still whacking them thousands of dollars because of the specialized equipment, right? And so is there another way of getting around it? And they ask me, well, you guys are paying me. I'm going to tell you everything I know. Obviously, you see, because I've bent your ear for hours now. But so I said, yeah, we could try these temper beads. Let's give this a shot. It's going to cost you money to requalify it, but I think we can make this sumbitch work. And the guys listen to me, the guys who are striking the arc and have the hood on, and I don't use infrared thermometers, or my infrared thermometer is a $1,200 one. It's not a $70 one that's only calibrated for carbon steel. Mine, I can adjust the emissivity level, so I can do cobalt, I can do stainlesses, I can do rusty carbon, I can do shiny carbon. But people don't understand that about the infrared. So I typically, when I'm testing, I use the temple sticks thermal crayons.
Yeah, because they're within 1 degree accuracy.
Perfect. They'll only give you the melting point. So you got, if you're controlling interpass temperature, which nowadays we all know to do, you're going to also have a top end. So my big time welders, we may be preheating at 225 because we're up 2 inches thick or something like that. But I've also held them to a 550 degree, and I'm not conservative. A lot of people are holding at 500 degrees, but because I come out of heat treating a little bit, you could about pour water on some of the steel, not all of it, but A516 grade 70s and stuff. You could pour water on it at 600 degrees and you're not going to hurt anything, okay? And so I've pushed it up to 550. And actually welding on big things, I find that your background heat kind of, once you stop keeping the heat on it, you're going to hover at about 450 degrees for the rest of the weld while you're welding. So you're not even coming close to that 550 limit that I set down. And I'm still passing Sharpies at minus 20 at 50 plus foot-pounds, so I'm beating the clock with my techniques. And we did the same thing on this P4 because I had to prove with a hardness on that, or no, Sharpies on that. And the P4, the chrome mollies, they'll operate down at minus 50 degrees Fahrenheit. And so I had to push my temperature limits down to like minus 50 in order to qualify for the repairs. And I got 50 and 60 foot-pounds at minus 50 degrees with this temper bead technique. So I know it's bulletproof. And so I've now brought this to building trusses. Now nobody knows it, but I can build some of these jumbo shapes so that each bead is stress relieving itself. So instead of walking from one side of the joint to the other like we're all taught in school, stuff like that, I'll get on some of these higher strength materials and I'll do the sides first, and then I weld the middle. So I never touch the base metal for my last arcs. And my middle beads are stress relieving those sensitive last beads that are tying into the base metal. So I'm actually stress relieving the toe of my bead, which is where all the stress is on when things start bending, right? And it's hard, it's by the heat affected zone and stuff. So I've been putting this into structural. It's not in the codes. I can't even talk to anybody about it because it's too far-fetched, but I know that my welds are more ductile in that heavy, thick joint because the pattern that I chose to have the welders weld it than just like we learn in school. But I wouldn't have been able to do that if I hadn't had my science experiment. And saw how things move. And I could tell when I was welding one way or welding another because it showed up on all the graphs in the strain gauges and stuff. So that's what I'm saying is just being an engineer doesn't mean that you've just got a job. If you're playing your cards right, we've got all this fantastic equipment, the fluke, the digital multimeters, the welders who go to 2 years and 4 years of apprenticeship or trade school, the skills-based programs, who got at least something in their hands that's burned in. It's not just read out of a book, okay? And then put those folks into an on-the-job setting where you got a pipe fitter who becomes a master journeyman after 16 years, or an iron worker who really doesn't get to be a journeyman until they got 2 years plus 2 years out kind of in the field. I think it's 2 years apprentice for those folks. But this is studied work. Well, I've been blessed to have a fluke to work with these amazing welders and see the tricks that they're doing and measuring it in amps and volts and the stopwatch for speed of travel. And nobody can tell you how to measure the speed of travel because you turn it off as fast as you can. It's not as fast as the welder stopped the arc. And then do you leave it running while he hems and haws and then strikes the arc suddenly in front of you again? You know what I'm saying? Yeah. Nobody tells you how to do it in the real world. So that's why we should be learning every stinking day. We should be opening up those books all the time. And if you didn't get it the first time, do it a second time, because then you're going to have a bug in your ear and you're going to run into, there's guys like me all over the US, and you'll know them and you can ask about them, or you'll run into Magic Tony, so tell you the way it looks like in his hood. We say the same thing. It's just he talks about it from welder's side, and I talk about it from an engineer's side. But at the end of the day, it's a fist bump and, yo, buddy, we're on the same page.
Mm-hmm.
He talks about little monkeys. I talk about the weld puddles jiggling because you've overheated the puddle. You know what I mean? Throw a little more rod in there. Let's get that chatter down, that kind of stuff. So keep the art in this business. Just because you sat at the foot of some prof in an ag ed program is no substitute for talking with that guy who's been on the floor for 25 years and just keeps showing up, one, because he needs his pension, but two, because he likes having an attitude.
Mm-hmm.
And we talk about attitude. My friend Wayne Western, who was one of the earliest national recognized CWIs of the year. We give awards in section level, district level at AWS, and then finally at national levels for CWI of the year. I'm an AWS counselor. And I'm proud as hell of that, because there's only 5 of us at most elected every year, and I'm part of the class of 2013. But that is one major honor. I've got a medal that when I give lectures, I should have the medal right on right now. I'm sorry, AWS. I apologize.
You should be wearing
it. I'm supposed to scrub my stuff. So Wayne Western. He was an instructor at Ogden Weber Applied Technology College, one of our skills-based programs. Okay, and Wayne had, he used the old paper hoods. He got arthritis in the neck. He had to retire out early, and all that kind of stuff, and before auto darkening. But he wrote an article for the Welding Journal. I think it's the article that he wrote, a little 4-pager that got him the recognition to get nationally recognized. We put his resume up and stuff. We love Wayne. But his article was, it had to do with why welders are attitude cases. And I couldn't believe my ears. He says, we have problems with accepting authority. I'm going, you just said my middle name. I can't handle anybody telling me what to do. We've got an overarching pride of our craft. Well, you better damn well believe it. I chip the slag off and look at every weld I ever made.
Yes,
and that's
sir.
The only reason why I keep showing up. I like to look at my welds, and he just kind of nailed all of us. Half of us can't even read. A bunch of us are dyslexic. A bunch of us, the words jumble around whenever we look at the stinking page, but we still figure it out, and we're all making decent money, and you guys are making better money than I ever made, because we were just wrenches as a kid, and now we're starved for employees. So if you want to wear your hair long and wear earrings in your ears, that ain't a problem for me, baby. I even told the ironworkers when we were playing this aluminum game, this pulsers, I said, you're going to give me one of your instructors. He's going to already be retired out, and it's a new deal going on. I want to have one of your kids with earbobs in his ears and tattoos up and down his arms, and I want him to look me in the eye and say, I don't care what you say. And then we'll show him how to weld this aluminum stuff the right way. And then you'll have somebody in your system who's going to, his dad was an iron worker, so you know that he's not going to ever leave you, and you're going to have money in the bank. And when Red and I are long gone, this guy's going to have it, and it'll stay in your system forever. So, those like me, don't be hard ass about giving your knowledge away. There's not enough people out there. You're only going to go to the grave with it anyway, hobo.
Yeah.
Come on, don't be so tough. So it really is about getting the word out, and we got to keep the art in there, because science, just like this picture is showing you here with the Z loss factor, they're never going to figure it out. The only way they can do is keep their fingers crossed and give us a formula.
I got a sidebar question for you. You had mentioned about welders being dyslexic, and you've welded with a lot of people. Have you noticed that that's a common theme with welders?
Yeah. It's not necessarily dyslexic. I had a helper who was truly dyslexic, and I had to teach him how to do die pen. And so it was see, watch, see, watch was kind of he told me how to teach him. I got to watch you, then you got to watch me. And I got to watch you one more time and I'll have it. Because, we all learn to work with our handicaps.
Mm-hmm.
And when I started teaching welding, my ex was taught middle school and stuff. And so I got to know the special education instructor. And she taught me that there's more than one mode of training, of teaching. And of course, we take going to universities or even high school and stuff, it's pedagogical, right? You stand in front of people and you lecture, okay? You may draw an example on the board, have them come up. And today's education, it's not even about having the right answer. It's about, can you psych out the problem and come up with a solution, okay? And this is what the 7,000 levels of education are. But I do know that a lot of our troubled students get pushed off into trades, and people thought of it, well, you can always get a job as a welder. It was the worst job you could get.
Right.
Well, yeah.
We're flipping that script slowly but surely.
I don't care. Just pay me,
Yeah.
And I'd go into meetings, throw down my card. What are you bringing a welding inspector for here? And I got that guy. We're going to win. And that's how I got the $2 million out of the Disney company, because they don't expect welders or machinists, tradesmen to put two and two together. And for a long time, the trades were a way for really smart people to succeed if they didn't have the money, the opportunity to go to high school or college. I've known guys who had an 8th grade education who became multimillionaire directors for Sunbeam Electric way back when. But that guy could also trace his National Guard service back to a Confederate soldier, because they have mentors and stuff like that. So I'm not suggesting that we go back to that by any means, but you got to realize there's lots of ways of skinning a cat. And sometimes, unless you're told not to by the code, bring all those cats and see which skin comes off the easiest. And so long as you're not cheating, do it.
Right.
Just make it work. That's how new things come about. And so maybe it means come out of your desk and look at this gruff old man whose weld just cracked at the speed of sound and watch how he fixes it, instead of writing me up. That welding engineer's disappeared. He's gone the way of all flesh. But he thought he was going to make career strides by sandbagging me, and you're not going to sandbag a guy like me. I'm just going to step up. I made a mistake. Okay. And let's go this way instead of that way. Because we're always just solving problems. That's why the art is there. Nobody gets a masterpiece if they just think they're going to draw it the first time.
Mm-hmm.
There's a lot of crumpled paper out there. And I love going in and working with craftsmen because I learn something new every day. And that's an important thing.
Right.
That's really what it's all about.
I only asked about the dyslexia thing because I get that a lot. Like I'm a bit dyslexic. Most of my welding instructors that work with me are dyslexic. And then we have a lot of students that come in, with or without their parents, or the guidance counselors. It's funny. They come in and they're like, yeah, I have a learning disability. And I was like, okay, well, we can work around it. What do you got? I'm dyslexic. Right. Well, shit, you're going to fit right in. Come on, come on in with the rest of the class.
Well, the ADD stuff is the same. It's a sister kind of to it. I mean, dyslexia is reading backwards and jumbling stuff up, and a lot of us have that. I have a little bit of it, but not much. So what the special ed teacher told me is, Oprah Winfrey's got the aha moment, aha, and then it matters. Well, because we're blue collar, we've got I'd like to say we have an inherent kind of inferiority complex built into us, right? We get no respect, okay? Other than what we give to each other, because we know the craft and a good hand when you see one and stuff. So the special ed teacher, and this is before Oprah, She said, if you look, you're going to see the guy, the gal in the back of the room, in the back row of the room, and they're never going to get a B or an A or anything like that because they're just not engaged. And look at them, they're looking down at the floor half the time. That's the depressive spot. If you want people to learn, it's you get to make their eyes go up and to the right. Up and to the right is the aha place. And when you're trying to remember something, think about where you put your eyes. You look up in the sky when you're trying to think of something. You don't look down at the ground, which puts you into depression. So she taught me to always show on the board with my left hand because I'm in front of an audience and my left is their right, right? So I'd stand to the right of my diagram and I'd point with my left hand. You'd see everybody's eye go up and to the right. And son of a gun, if I didn't get in the top 5% of the welding instructors every year, and guys would buy me beer. After years later on, they'd see me out on the street. They'd invite me in for a beer at some bar or something. And, so like I said, people do anything for you when you're a craftsman and honest about your craft and like it. So the dyslexia, the way we don't teach our craft, our trades instructors this stuff, but I think if we worked a little bit more with special ed, and not like you're a dummy, you're not being trained to the training mode that's best for you. And there's 4 of them.
Mm-hmm.
Well, some people, I called it the golf pro, where I would reach around and grab their arms in the booth. I said, you hang on to the stinger, but I'm going to give you the move. I'm going to give you the hand.
Yep.
And how to hold and stuff. That was so some people like a tactile. I mean, granted, we got to be careful and ask and all that,
Yeah.
but some people need a tactile show and tell.
That's how my instructor taught me. That's how I teach my students. I said, hey, I'm going to hold your hands not in like an awkward way, but I want you to relax. I want you to feel what your hands are going to be doing as we're moving through this piece, or as we're, vertical up, vertical, overhead, whatever. I'm going to put your hands where they need to be, and just relax. And once they relax and go into it, they kind of get that tactile feedback, and they're like, okay, this is what it's supposed to feel like. That's not what it was feeling like a minute ago, but okay, I get it now. And then they get that aha moment. I call it the eureka moment. You can see it in their eyes. Their eyes light up and it clicks.
Yes. And that's what we're trying to get at as instructors. And that's why, because we always have to go to lecture, we got to talk metallurgy.
Mm-hmm.
And so you're going to be in that classroom situation where you're going to lose half the guys. There's going to be another half of the guys in there who want to learn the geometry, want to learn a little bit of trig. And the other guys, I just like welding. I don't want, well, fine. But there's so much opportunity. You could be there's so much opportunity
Mm-hmm.
in this business. And so don't be sitting there saying, I don't want to read this because I just want to weld. Tough it out and try and read that sucker and try it again. And then you've got at least a baseline. You can start talking to your instructors or the gurus you happen to stumble in on. And you'll have at least enough vocabulary to understand what these folks are trying to tell you. That's important.
Mm-hmm.
The student has to be prepared to understand what you're throwing down. That's my biggest problem. Okay, I just go. And I lose a lot of folks. But the good instructors, they're doing hand motions. They know, like you're saying, you just knew you needed the tactile stuff. Some guys need the lecture. Some folks need to just watch how it's done. I have to listen and ask questions because I don't understand what people say to me a lot of the time.
Mm-hmm.
Okay, I'm kind of blockhead. That's my issue. Probably why I couldn't hold a job for very long.
That's
and you get pissed off when people start going, you can't. I'm that kind of stuff.
I got to see it and put my hands on it, and then I can understand it.
Yeah, and that's our whole tribe. And so we don't and that's also our whole tribe, even if we don't speak the same language. I worked with a lot back in the 80s and the early 90s. They brought a lot of illegals into the shops because you could build a two-tier wage program. That's gone away now. Okay. But it was tough being put up again, and it caused a lot of animosity. And those, the folks coming across the border, they have a different cultural aspect. You don't just, when you're finished with your job, you don't just go pick up a broom and start sweeping. That's disrespectful to the boss. Whereas if you're a cowboy, if you're standing around with your hands in your pockets, you're going to get chewed out. And if you don't just pick up a broom until the boss sees that you're sweeping instead of welding, you're lazy. Well, that's different for the folks coming in from Mexico. Okay, it's disrespectful to the jefe. Not to mention they don't have the schools that we used to have. I learned how to braze cast iron. I learned how to weld cast iron. Break it, weld it, break it again, and weld it again. See if you can braze it this time. See what you're getting. We were allowed a lot of. We taught air arc. Air arc is not even taught in this AWS Sense School program. And you can screw up a lot of work by not knowing how to use an air arc, instantly. So there's limits to what our instructors are able to do. We don't have budgets. You've got a timeline sitting on you. For a while, when I was teaching nights, it was all body count. If I didn't have 18 students, they'd sometimes close the program. And sometimes I had 23, which gave me, for a 3-hour night, 5 minutes a person.
Yeah.
And they're paying for that. And we had one of the for years, we had a vocational education group, just like the Board of Regents for the universities. We had Board of Regents for our voc ed schools. In Utah, we had some of the finest vocational education programs this side of New York and the eastern states, where they had true trade schools and stuff like that. We're not real big on unions out here, but our trade schools were every bit of as aggressive as any of the crafts, if you will. So it's really difficult trying to meet today's demands with what you're given. I'm totally sympathetic to how difficult it is. And I'm totally sympathetic to a guy coming out of school and not knowing what to do on the shop floor. With some of these schools that you pay for, they won't even show you how to read a tape.
Yeah.
You just weld.
I was talking to we just got a new instructor at the school, and we were talking about that the other day, about how, a lot of instructors, they won't let the students use certain pieces of equipment because the mentality is, oh, the students will just break it. Well, how many times have you, got together a group of students and trained them how to use that piece of equipment properly versus saying, just go over there and use that piece over there? Well, then they screwed up because they don't know how to use it. But if you train them how to, if you teach them how to use it, they're not going to tear your stuff up.
Right.
After probably the second, third week of my class, my students can operate every piece of equipment in there because we do a period of instruction and they put their hands on. We do the same thing. I'm going to show you. Now you teach me. And then, we go back and forth, put them in a group, and they work together and they learn how to use every piece of equipment in there. And other than outside of normal wear and tear, we usually don't have anything that breaks.
Mm-hmm. Mm-hmm. No, and they're safer too, because now you've got 100%. The gang looking out for each other.
Yes, 100%. Everybody knows the safety.
The student gang they're a phenomenal group. Even the people who hate each other still love the gang.
Mm-hmm.
You know what I mean? So it's a wonderful thing being a student in a welding class.
Yeah.
And you get information from the folks who paid more attention than you did. You know what I mean? So I'm totally sympathetic, but I love the art, and I'm not going to ever give away. There's a limit to how far the science can take us on this stuff. Ultimately, you need the hand of a welder to see how it's flowing in there in order to really get it right. And then if you could give that welder some concept of heat input and what we're doing with heat input, or maximum hold times and quench rates, things are going to get real sophisticated about quench rates here in the next 30 years.
Mm-hmm.
It's all this preheat and temperatures like that. Those are just accelerator pedals for quench rate. And it's how fast you get out, and it's how fast you get out of certain zones that's going to make for a high quality weld, not did you preheat it at this and did you stay under that. There's a lot more to that. And I'm sorry I'm an iconoclast, but I just see it in my experiments, and I've run a lot of experiments, and fortunately some of them have been paid for by my contracting customers, you know. We had a 2205 duplex stainless shaft and 5-inch diameter shaft, and the engineers wanted them to weld it up with 309 with 2205 filler metal. And well, the machine shop hired me to test it, and snapped like glass, okay? And because they were worried about liability. If it cracked in the service, you always come back and bust the welding company, right? Well, it turned out that 2205 filler metal, when you're joining to a carbon steel rod, it leans out the chromium so much that you get, they call it a sigma phase, which means it's just going to crack like hell right along the heat affected zone. And sure enough, I said, they've got a bad welding procedure. Wait, these are the engineers from New York. Who are you to say this? I said, I don't really care. I'm just telling you the way it is. Now, you want to stop the contract now? You owe me $1,100. You want to keep it going? It's going to cost you $1,100 every time we run this test. But we'll figure it out. And I'll tell you what we got to do, but I'm not going to tell you for what we did. And so, okay, what are we going to do? And I thought we could. So you want low heat input, but you want to fill this stuff. So they were using a pencil point jig fit up because they turned it on a lathe. That doubles your amount of weld input, right? Because you're doing circumferences all the time. So get rid of the pencil point prep, do a chisel point so it winds up making V grooves. We've just cut down our filler metal by half. And this filler metal is $45 a pound, okay? Mm-hmm. This is, okay, so first, we're going to change your joint design. Well, they told us to do this. I don't care what they're saying. Then write a request for information and request permission to use a chisel point. This is going to make a difference. Now let's try a spray transfer because we can be there and gone. Well, the machine was an old wire feeder, and they couldn't get the wire to spit out wire fast enough. So we tested it, and it just broke. It just tore apart. And the welder now, he's all pissed. He said, I did what you said. It didn't work. He ran up and down, telling the boss I'm an asshole and all that kind of stuff, you know. And I said, wait, we know the filler metal now, and we're not going to weld it with 2205. We're just going to weld it with 309 because it's stainless to carbon, okay? And it's just that problem. And, well, but it didn't work. I said, yeah, but it's not breaking along the heat affected zone. At least the bead's just tearing apart from all the lack of fusions you got in there because you couldn't spray all the time and you didn't know what spray looked like. Mm-hmm. I'm sorry, I set us up wrong again. My problem. So we're going to do this with good old 309 flux core. You know, we're go right back to the simple. It's going to work. So I'm measuring heat input. I'm doing everything. I'm measuring the fluke and all that stuff. And son of a bitch, if it doesn't bend like just sweet like putty, we're up there at, I think we only needed 70,000 pounds per square inch. So we got 78,000 pounds per square inch tensile. You know, so sometimes you got to experiment with this stuff. But sometimes what one of my bosses told me, the president of the company, the machine shop, he says, Bill, if your customer tells you that the sun rises in the west, they're wrong. And there's nothing you can say that's going to make them right. So don't buy into it. Stand your ground. You know the sun rises in the east. You don't have to blink. And I've used that more and more, especially when I get confronted with theory versus what I've personally seen and measured. Mm-hmm. Measurement being the key. Don't hope, know. The only way we know is by following procedure and measuring the results of our application of the procedure as skilled technicians trained in the procedure. I'm done.
No, that's a perfect way to end it, man. I definitely appreciate your time. I've had a blast talking to you. I've learned a metric crap ton of information. I really appreciate you stopping by and informing the listeners. I'm definitely, if you don't mind, I'm going to hit you up periodically for some different information. I enjoy talking to you because you're just as well. You're probably more passionate about this than I am, and I hope that at my age, I'm just as passionate about
That's
welding
better.
and everything.
It's not just about your pants.
Yeah.
I want your hair on fire, baby. Let's burn a hole in that beard, and maybe we'll get to see your chin again.
Man, I
did
haven't seen that thing in like 5 years.
I sure appreciate it. Thank you very much for getting me out of my cave.
Oh, no problem. I really appreciate it. I'm glad Douglas sent us up to
Thank you,
chat and
John.
everything.
Yes,
John's an awesome
send
guy.
him a thank you too. He was secretary for me when I was chair of methods of inspection at B1 for AWS.
Okay.
Oh, and by the way, all you young folks out there, younger than 35 or something, getting into welding, become members of AWS. It's the information, your dues will pay for it. I got a whole career out of my dues. Also, volunteer for committees.
Yep.
It is phenomenal. Become a participant in your sections. Become political in this stuff. We need the people to come in. And I'll tell you, it is a hoot, the people that you meet from all over the country. As a district director for AWS, going back to Miami once a year, and then our district meetings up in Jackson Hole, Wyoming. Wasn't that nice? Or Rocky Mountain National Park. I don't know what they do in Chicago. Maybe they take the elevated train. But it is fun. And the younger you start, now you're going to have your kids, you're going to do all that kind of stuff, and you got to make your stripes. So you're going to be busy. But when you can volunteer for these things, you start getting regional recognition, you start getting national recognition. The earlier you get that, the more fun it is. That's
100%.
all I can say. Participate. Be a player. Do what Jason's doing. Too much fun.
I've said it on the show before that it wasn't until I joined the AWS back in 2014 that's when my career started taking off. And not because where I was a welder, it was because the networking opportunities. I just did a full episode on networking with the AWS for the Weld Wednesday edition, and I had my immediate network that I talk to all the time, the folks that I met through the AWS. They're at the same spot, in their journey as I am in mine, and all of our careers have just been taken to the next level because of the connections and the networking opportunities with the AWS.
Yeah, right on. It's a ton of fun. It may be not for everybody, but if you've got your own personal goals for having a career in welding, you will further your career by starting to participate in your trade organizations, and AWS is ours, and it's a damn good group.
All right, ladies and gentlemen, thank you once again for tuning in. I had a great time chatting with Bill on this episode, and I hope you all enjoyed listening to the conversation. I'm going to go ahead and post links in the show notes to all the figures that Bill and I were discussing about, as well as the articles on the driver tubes and the Mars rover project. Don't forget to check out arcjunkies.com for a list of episodes, as well as merch links where you can pick up Arc Junkies hats, shirts, and hoodies to support the show. All orders will receive a free sticker pack. Make sure you subscribe on whatever app you're using to listen to the podcast so you never miss an episode. I got a lot of cool shows coming out for you in the near future that you won't want to miss. Thanks again for the support, and until next time, make every weld better than your last.